know to understand the right uses of XYZ tool that I'm going to introduce in a minute, right? Okay.
हमारे वाले में लिंक कहाँ है?
Sorry. So I can start in this way. Okay, in today's world of IT, okay, so why we use IT? Because someone has some idea in their mind, and this idea they want to provide to everyone, so everyone can use their idea. For example, someone has idea of social networking, so that is idea, and that we convert it into the app called Facebook. Or someone has idea to stream the video or the movies, then that become the Netflix. So everything starts from the idea, or maybe sometimes we have a requirement from the customer, whatever they're looking for, and based on the requirement or based upon our idea, okay, what we do, we mostly hire some developers, okay, and ask them to develop a product based on this idea or the app on this idea. Mostly we develop the let's go website like facebook.com. Okay, web app. Okay, but after they develop the web app, and they have to do one more thing, they have to choose some language, what language they should use. Okay, so they can go for Python as a language, or PHP as a language, Java as a language, JavaScript as a language, multiple programming language they can use. But mostly nowadays, if you talk about any app, okay, one particular app, when you talk about, for example, if I go to facebook.com, if you go to one particular app, it look like one app. And what you see here is the front end, is the front end or the view. Okay, but behind the scene, when you see this search button here, Facebook is one feature. You can have chat box here is one more feature. We have a messenger here at the top is one more feature. We have a posting here. There's one more feature. So one particular app now have multiple features, and almost every feature what you see as it look like it is just one app. Is one app, and everything is over here. But technically behind the scene, one more guys, why this screen is coming up. So when you see any app, it look like one single, it is, or one single service, maybe I can use the term, okay, but it is not the fact behind the scene. The fact is, okay, when you talk about, let's say, the Facebook, just one example, okay, so the search button can be handled by different team, and that particular part, there's a search button or search bar here. It could be written in very different programming language, let's say in Java. For storing the data, they are using very different databases. Let's say they might be using maybe using Cassandra database, for example. For example, if you go for Facebook chat message or chat box here, okay, so this can be handled by a different team, written maybe in different programming language, maybe Node, just go JavaScript, and they may be using a different database called HBase, for example, a database. And when you go for Facebook internal account settings, they are using Oracle database, maybe written in a PHP as a language. So my point is, one app look like one single app, but behind the scene, your front end is connecting to multiple individual server or the services, and every server is managed by different team, different databases, different programming languages. Okay, and they somehow connect to each other, work in a collab with each other to present you as a one single app. Okay, so this architecture in the high level is known as microservices, where every component or every part of the app is one individual service. Okay, this is called microservice, and all the service, all that part, all the part, okay, all the part work together, okay, and become one single app. Okay, so mostly if you go for Netflix or Facebook, these are complete example of microservice architecture. Okay, and any app that is written in multiple programming languages and present as one single app, this concept is known as polyglot. So mostly all the application nowadays is kind of polyglot. Okay, this is one thing. Okay, and now why it is so important to know this point. That means that means if I try to draw in this way, so there's a one service running called search service. There's one service running called chat service. There's a one service running called posting service in Facebook. There's one service running called messenger service in the Facebook, managed by different servers, by different team, by different programming languages. But finally, it's app, right? And this app is running in one server, okay, one computer. Maybe have some IP address. Maybe this IP is IP1, this IP2, this IP3, this IP4, and some maybe due to some XYZ reason they have to also connect behind the scene, because there's a possibility whatever post you are posting in the future I want to search. So this post is been posted by the post services. Okay, I'm talking about the Facebook post here, this post. Okay, but the search bar is helping me to search some of the posts, whatever post in the history in the past. So this app should have a connectivity with this app, or maybe this app should have a connectivity with this app, or this will have connectivity with this app. So somehow all the microservices connect behind the scene using maybe some network, so that they can sync with each other, they can communicate with each other by depend upon the requirement to a requirement. Okay, but the challenge is, okay, this setup, let's say this app has been developed by the developer, so we hire the developer and say they have to create this app in some certain languages. They develop it. After the development done, okay, some of my team, my developer guys are the one who develop this guy. Then we have one team, mostly the operations team. Operations team is handling the remaining part. What is the remaining part? That is what we are going to discuss in a minute. Okay, but one of the part is they have to run this app in some server, that is mostly known as deploy or deployment. So they deploy the app here in some server. Some other team might deploy the messenger app in their servers. Okay, and so on. And all the app or microservices here connect to each other, become microservice architecture. Okay, but this, let's say this one time setup, development is one time, let's say, and deployment is one time. Okay, but main thing what we as an operations team has to work continuously for every second, every minute, okay, is to maintain, because this is my complete app, this is my entire site. Okay, so as an engineer we have to maintain the reliability of the site. Okay, so one of the primary responsibility, okay, as a SRE engineer, okay, that is mostly, sometimes we can use the word DevOps engineer, there's some, but maybe some small difference, but as SRE engineer, the one of the most important responsibility is the reliability of this site. Okay, this app of messenger should not goes down. Okay, my post app should give a better performance. It is not like this, I click on this button and it takes a lot of time to come up, and I post something over here, it takes some time to post. I have to maintain the performance. Okay, and when I talk about the performance, if you talk about the reliability or or maybe if I talk about the fault concept, we talk about the resilience. What are the term right now you say at this point in time? Okay, we are very much keep on observing the entire site. This is called observability. Okay, because if this post is let's say if search is slow down, or maybe I can say the post is slow down, this app is slow down, maybe because of the memory issues, RAM, because my CPU is not been properly distributed because of the time what CPU is giving. Okay, maybe we have network issues we have a hard disk issue, storage issue, database connectivity issue. We have no idea. Okay, any one issue will lead lead the this app slow down or goes down maybe. Okay, and if this goes down, it is not only the post app, but it might also impact my search app also. But search is depend on the post app, for example. Okay, so if one goes down in the microservice architecture, okay, almost other part of my application also slow down or maybe goes down, depend upon how they connected to each other behind the scene. That is called cascading effect. So in the in the microservice world, the cascading effect is very commonly seen. Okay, but the challenge here is if my search is slow here, okay, it is very hard in the terms of troubleshooting. Okay, or I can say the word visibility. Okay, why it is slow? My search is searching slow. Okay, why slow? Because of the issue on the search app, is issue in the hard disk of the search server, it is issue in the network part, is there some bug come in this app? Okay, or maybe they depend on other services, they are slow down, and this service might depend on other services, they might slow down. Okay, so the challenge is the visibility, right? Because if he does not know the right exact area that is causing the challenge, go and fix the issue of memory, who can fix the issue of network. So we have the engineer who can fix, but what to fix and where to fix? Okay, so this is very big questions to be asked, right? Because search is slow. I can't tell these engineer who are managing this app and say this is your fault. No, this is not their fault. That could be fault of other team or other app. Okay, so what we want this entire independent service made by different team. I want to see the entire visibility. I want to observe this guy as a single plane of glass. I want to see something like this. If this service is kind of this service, if the service kind of this service, I can see how my network packet is flowing. I want to see how much time it take between these two connections happen. Let's say 1 millisecond. This is 3 milliseconds. So we know till that this guy always take 1 millisecond, 3 millisecond to connect to each other. But maybe today what I figure out, now this time will increase to 30 milliseconds. Okay, so there's a root cause here. The cause is here. At least we come to know. Then we can go more deep into this to understand what is the root cause. Why now this guy is slow. We can initially maybe my post I will take 30 milliseconds to connect to this part of the microservice. Now it go to 30 milliseconds, 10 time increase. This called delay happen or latency happen. So why this slow? They're slow because of network issues. They're slow because of some issue in their memory or the service. We have the application bug come up by chance some of the reason. So we can go for further for root analysis. Okay, the point is what I'm talking about. Okay, as a DevOps engineer or the SRE engineer, your main role is to keep on observing. You should have complete visibility. You can go deep down to understand the root causes. If some cause gonna come up, and believe me, guys, almost every time you will find some other cause somewhere in here, and we have to keep on analyzing. Okay, and after analyzing, then troubleshooting would be one the big deal. Okay, because nowadays we don't troubleshoot much. Okay, depend upon what architecture you have created. So if something is not working, okay, if this app is not working the way it should work, we terminate this entire instance and launch a new one very quickly. Okay, whatever the tester one, this could be one of the approach we can use. Okay, because we never know, I don't know what settings and what configuration will be changed by someone manually. So we have a one copy of this guy. We'll take this copy and quickly relaunch and set establish the connection here. Yeah. And nowadays, launching the new setup is very quick, very quick. Within a second or millisecond, we can launch the new instances. Within a millisecond, we can connect with this new instances, and this is because of the container technology. So we have a container technology. You guys might know as a technology name, and there's one of the products in the container technology is called Docker. Maybe we have many more like Podman. We have a Cryo. We have Podman. There's a lot of tools available for the container technology. One of the tool is Docker. So what I can say, Docker is a tool. I can tell the Docker. There's a one server running or services running.
Android 13
okay. And those who by chance does not know the Docker, I just want to tell you very quickly in a minute. Okay, in a minute. So whenever you want to launch any operating system, okay, if you want to install any operating system, so for installing any operating system, there is 4 ways available in the market. One way is called bare metal. You can directly install the operating system directly on your hardware. Okay. Or other ways you can use virtualization like VMware, EXXI, or Hyper-V, KVM, Zen. There are software available, and you can launch one OS. So this is the hardware you have. On the top of hardware, you have one operating system. And on the top of operating system, you can install one program called hypervisor that will give you virtualization capabilities. And on the top of this, you can launch multiple OS and run multiple OS together. Those are VMs or the guest machines that I think you guys know. One of the software name is called EXXI from VMware, Hyper-V from Microsoft. We have KVM from Linux and open source. Okay, and third way to install the operating system using cloud computing, you can use cloud like AWS cloud or GCP cloud. For example, if you use AWS cloud, then the service is EC2 to launch the operating system. Okay, and fourth way is called container technology. And we have multi-product. One of the product in the container is Docker. The beautiful thing about the Docker, if you guys know already, I believe, okay, if you launch any OS in virtualization, maybe in the cloud, maybe in the bare metal, okay, it takes some time, maybe 1 minute to 1 hour, depends, okay, to install the operating system. But in the content technology, you can install almost every operating system and run any and every operating system within a second. Just in second or one less than a second, you can launch the entire OS. Okay, so that's one of the beautiful parts. So whenever you have a requirement that you want to quickly launch the entire operating system, okay, then always the perfect choice would be container. So this is one of the use. There were many more reasons why we the container technology or containerization concept. But one use is whenever you want something to be very quick and very rapid, okay, you can launch the OS using container technology. Same thing we can apply here. So if some of the service goes down, again, guys, it's all vary from your current setup and the architecture in your respective projects. Okay, so if something is failing, rather than we invest the time on troubleshooting why they're failing, so why not we can terminate this entire instance, entire app running in this instance, and launch a new instance, a new OS. Okay, and here I want to save my time, so we can use a container technology like Docker who will launch this OS within a second, less than a second. Okay, less than a second. Okay, and we'll establish the connection with this guy. And I want this to be automated. It to be automated. So what I want someone who keep on monitoring my this app, someone who keep on monitoring my this OS. Okay, and if they find this OS is not working, or I can create some rule. I can get the rule if this OS is or this app is facing this kind of trouble. Okay, so in this case, terminate this OS and relaunch the new container or new OS and connect with the new OS, your other services. Okay, I want this part to be automated. This concept is mostly known as orchestration. So I want this to be orchestrated based upon my rule or my conditions. Okay, so whenever guys you want to orchestrate something, you want again some automation tool who can orchestrate this part. Okay, this part means if I tell you one more time, for example, I want my OS. Okay, if the OS is shut down or terminated by XYZ reason, you guys know one thing: OS is the one where your app is running. Okay, app is the one where that is connected to the client. Okay, or client or by some other services. Okay, so for example, this app is the front end. We are the client who is connected, but there's some service kind of other services in the microservice architecture world. So what I want, I want some tool who keep on monitoring my OS where my app is running. If OS shut down, OS terminate, app is also terminate, and we have a downtime. We have a downtime. So almost every company, guys, is struggling. Okay, no one till date has 100% foolproof solution to how to make your site or app up 100%. Okay, so we have no guaranteed architecture available. So right now, guys, Gartner, you guys know, Gartner is the one who is doing a huge research in this part. They also, I think, published recently some of their architecture, and they say if you're using this architecture, that will make your app up 100% in all the possible scenarios. Okay, that is again the theoretical, but there is no as such architecture you can you will have in any possible scenarios. Will can go as close as possible, 99%, 99%. That's a different point, but 100% is not there. My point is you can your app can go at any point in time. So what we want if app goes down or my OS goes down, okay, or it could be any other scenario also. Maybe OSs keep on running, but app goes down, or app is there but OS goes down. That makes OS also goes down. Okay, or maybe we have some kind of connectivity issue, networking. So it could be any issues. Okay, so what I can do here, because manual is done by human being and human being are slow, and if you really want almost close to 100% uptime, so we can't rely on the human being. Okay, so we have to go for some automation tool, and one automation tool, what I am looking for here is they keep on looking for this site or this services or this microservices, whatever says same thing. If one of the microservice or the site or app goes down based on all the conditions whatever write in my automation tool, so what they do, they will relaunch the new app by launching the new OS. So entire new OS they launch, entire new app they launch, and they re-establish the connection with this new system. New system. Okay, that could be done completely in automated way. So there will be no human manual intervention, and everything is done by automate, means done by some kind of program by the operating system. So it will be very, very quick. Within a second or less than a second, you can see your new OS with a new app to be launched and we establish this connection. So rather than we troubleshoot the issue, okay, because right now the company is not looking to check your intelligence, how intelligent you are in the troubleshooting part. It was the long back. We are pure engineers and keep on doing a lot of troubleshootings to showcase our skills. These nowadays they are not looking for your skills as such. Okay, they say your app should not goes down. If it goes down and if fold happen, how can you tolerate the fold? Let's go fault tolerance. Okay, how can you make the system very resilient? If something goes down, still you won't get the connection lost. Okay, how resilient you can create the setup. And for this, we have to remove human intervention, and for this, you have to come up with some kind of a lot of different approach. One approach, this is what I'm talking about. If something goes down, don't troubleshoot, rather than recreate everything. Only thing is how fastly you can recreate, how fastly you can launch the new setup. That's called provisioning of the new setup. That makes the difference. Okay, and that is one of the core reasons. Okay, if you want to launch the new setup with OS and app running, everything together launch very, very quickly. Here the role of Docker come into play, or I can say the container technology come into play. The Docker is the only way who can launch the entire OS. Plus, OS is also not enough. In this OS, they can launch the entire app, run the entire app within a second or less than 2 seconds. Okay, with the help of container technology. Okay, so that something goes down. Okay, my Docker can launch this OS very quickly. And the world of Docker, this OS is known as container. So when I say container or the OS, it is same thing. Okay, but only thing that Docker does not have, okay, they does not have a capability to keep on monitoring the system, keep on monitoring for any fault and some issues. Okay, and some of the issues when they terminate this old OS and launch the new container. So they don't have this capability as such in built in the Docker. So for this, we need some other program. That is what I was talking about as automation program. And when they see any fault, they can able to tolerate the fault and they can do some actions based on this. Okay, and those kind of tools are mostly known as container orchestration engine, COE's tool, container orchestration engines. One of famous name for the COE in the world of containers called Kubernetes. So this is one of the good use of the Kubernetes. There were many more use, but one of the good use of the Kubernetes help us to make your setup highly fault tolerant. They can make your setup highly resilient, depending upon how you set up the Kubernetes. Okay, so this is one of the tool. It is not only tool. We have some tool from Docker also. So Docker has their own tool kind of computer of Kubernetes called Swarm. That's also we can use, but mostly we use Kubernetes. Okay, that's what the use of the Kubernetes come in play. Okay, so the point is there's a possibility this app, what you see is search app in the Facebook, is managed by so let's say again we come to the same story where we started. So we have an idea, requirement come from the customer, and they say, hey, we have already one app, but I want to get one more app. It's called search app. So we hire some developer. We have already they're creating this app, and let's say in the language called Python by some database also. That's what they created. So these are the starting point, and the end is I want to deploy this app. When I say deploy, means I want to run this app in my production environment. And let's say this is a production environment where the client is connected. That's what I want to deploy. So that my customer, final users over the internet can able to use it, this app. Okay, so this is my final motto. I want to take this app to the market. Only goal is a game is from the idea or from the ideation stage to the deployment stage, this end to end, how much time it will take. The game is TTM, time to market. Okay, time to market. Okay, and if you think you will take a lot of time, maybe a year or 6 months or 2 months, so that is not as such kind of good thinking in the today's world. In today's world, we are in the complete competition. Okay, what idea you are having, same other competitor might also have the same idea, and the goal is who is the pioneer, who will come first.
Docker Kubernetes.
They will take the entire customer. For
Sub
example,
project are IKIR.
someone has idea called car rental company, right? Who come first, Uber or Ola? Which will come first, they will take the market, right? Or maybe it's not about only one go. Okay, they have to keep on a lot of different marketing plan. They have a lot of different features they keep on coming up. So only starting is not, every day, every week they keep on coming with a new marketing plan, new feature and facilities. Then also we have to develop, right? And that also we have to deploy in the process environment so my customer can use it. Okay, may both the company, let's say Uber or Ola, come with the same idea. Okay, but whoever deploy first, let's go release first in the market that idea by using obviously app, they will take the customer. So example, Uber will come first, then they will, Ola customer will very quickly move to Uber. So retention of the customer is not possible in today's world. Whoever come with a better plan, better idea, my customer will go there. That's what the challenge is. And that is the reason, okay, your time to market is very important. How fast or how rapid you are. So your company business guys, entire business guys, COEs, your company executive guys, they just keep on thinking how they can make the entire methodology to be very, very quick and very rapid. Okay, and there they have to use a lot of technique, a lot of methodology, a lot of approach to make your time to market very, very quick and very, very rapid. Okay, and one of the things what they have to do to rapid time to market or faster time to market is with using automation. So they say wherever anything is doing manual, remove it. Okay, everything we have to do in the automated way. Automation, because manual is done by human being, and human beings are slow, they can't work for 24 hours. Okay, they do mistakes, then it's again very hard to troubleshoot. Okay, but if you go for automation, that is completely done by computers, by the program, they will never do mistake. They don't work 24 hours, and they will do very, very quickly. Okay, whenever we ask them to do, and they will never do mistake. Whatever we ask, they will do for us. So technically we have to go for automation. Okay, but where? Everywhere. Okay, from the starting point, development, till the deployment. Okay, between these guys, there are a lot of different phases come in between, a lot of different stages come in between. So it is not like this that you have an idea and you develop the idea and you launch the app to the to the production environment and release to the market. It won't work in this way. Between these two endpoints, we have many different stages come up. Okay, and those stages we will go explore in very detail, and those stages handled by different team, they do many things in between, and finally they release the product. Now what are those things? That what we'll discuss in a minute. Okay, but understand one point. Okay, just one point. Okay, from the idea or new feature you want to add in your app, from here till the release, okay, we have to do everything whatever is possible as automation. Okay, that's what we have to do. Okay, and automation is not the only thing. We have to do one more thing. Okay, we do one more thing. We have to use certain technology who can do the things faster also. Okay, what I mean by this? For example, let's say one of the things what I do in between, let's say this part, is testing. Because obviously your app has been developed. You're not going to launch the app directly to the process environment to use your public or any clients. We have to do some test. Are they doing the same thing what we are looking for? And the testing again, the big world will go a little more deep into this topic. Okay, testing. But for testing, what we need an OS, we need a server where we test. Okay, we test. But if you test something, you need a server. But who will launch the server for you? But testing is not the one thing that we do once. I'll again, when we go more deep into this topic, I will explore more about what I'm talking about. But point is, testing is not one thing that you do once. You keep on doing. New code gonna come up, you again test. Again, new code gonna come up, again you test. And every time you test, it is good practice. Okay, whatever OS you are having, you have to first terminate the OS and relaunch the new OS. Then you test. Again, new thing gonna come up. Again, you terminate the old OS, reinstall new OS, and then test. Why? We will discuss if you want. But this is what the mostly the methodology we use. My point is, if you test 100 times a day, 100 times you have to launch the new operating system. And that's called, you have to set up the new testing environment.
I have no idea who this is.
And then you test. Okay. The point is, setting up this new environment, I can automate by somehow. Okay, by somehow.
Nothing else.
For example, if you want to launch any new operating system automatically, and let's say you want to launch in the cloud, then we can use Terraform. Terraform is one tool available in the market. I can ask this tool, they will go and launch the OS, let's say in AWS cloud using EC2 service to launch this OS automatically. This part could be automated. And after this OS launch, then I can install my some testing tool. Okay, or software and configuration automatically. So again, we have some tool in the market who can do the configuration automatically. This is called Ansible. This is one tool in the market, or Puppet or Ceph. Many more tools also there. You can do the entire configuration completely automate. So automation, for every area we have automation. For launching the entire OS, for setting up the entire infrastructure. So we have an infrastructure as a code tool available in the market for automation. One is the example Terraform. And after OS launch, to configure the OS, we have configuration management tool. This is called Ansible, or Puppet, or Fabric, or Ceph. There are a lot of tools available in the market which we want to use. We have it. Okay. But point is, automation we can do. But the only challenge is, okay, even though you're setting up everything in automated way, but it takes some time, right, to launch the OS. It takes some time to set up these tools. Okay, so it was not faster as what we are looking for. Can we do something? Can we decrease this time also? Yeah. Automation is obviously faster than manual because it's done by computers, by programs, by code. But it will take time because they are setting up on the fly, on the real time. So can we decrease this time also? Yes, we can do this. We do this. How? With the help of container technology. That we'll discuss in some part in very detail in after some time today. So container will help you. So what we can do with the container, we can just have this environment pre-bagged concept. Let's go pre-bagged. We have pre-set up this environment. And I can ask the container technology like Docker and then launch one click and then dash set of launch. We don't need Terraform there, for example, in this example. We don't need Ansible to configure. We have everything prepared, pre-bagged, and we just use container technology like Docker. And one click, the entire environment launch. The point is, we want automation, but I also want faster in the world of automation. Okay, so you'll use multiple set of tools together. We'll go. Don't worry, guys. If you're not able to understand this, if you're very new in this concept, don't worry. When I do the demos, you will connect the points what exactly I'm talking here. But my point is, okay, in today's world, whatever you're doing, you have to always think about this. That's the key. Time to market means from the idea or new feature, or maybe app is already running. If the bug or security bug or any vulnerabilities, again we have to fix. By asking the developer to change the code. Okay, so whatever you do from the requirement, from the customer or new feature or the bug fixes to the release part, okay, whatever you're doing in between, a lot of things you have to do in between, that we go more deep discussion. Okay, can we make it rapid? Can we make it faster? Can we make it automated? Okay, if we can do so, it will drastically decrease the time of launching the new feature. And faster you move to the market with your idea, okay, you will get a more business. Okay, and guys, one tip I want to share with you. For me, it is very important tip in getting new jobs, better hikes, or the jobs also if you're a fresher, or hike in your profile. Okay, and this is the guys very interesting tip. You guys might know, I don't know. Okay, if you follow this step, I can give the guarantee. Okay, the growth of your career in terms of hike or better profile, better project would be something like this. Exponential growth. Okay, the tip is that I see in the market, it also helped me to grow, getting multiple company and panel with me or Linux World. I think almost all the top company we have now. Okay, is how can you help the company or the businesses in getting profit? That's all. The gain is the profit. Okay, and there's two ways to help the business in getting profit. Once you could be a sales and marketing guys to sell their products. So more products they sell, they have more profit, obviously. But obviously we are not from this background. We are from the tech background. So in tech perspective, how can you give them profit? Okay, it's simple. Every business nowadays working IT and digital, and almost every company investing, let's say 70% of their expenditure on the IT using some technologies. Okay, so example, let's say if you look at Netflix, Netflix is using AWS cloud mostly entirely, and let's say they are giving $5 billion, just I'm giving hypothetical number, every year to AWS cloud. Okay, so in this tech stack, what Netflix is using as a tech guy, what can you do? How can think like FinOps guys? Okay, how can you optimize the architecture using AWS cloud without impacting the performance, without removing some of the features? Okay, can you decrease the tech users? Means can you optimize the cost? Okay, if we can do it 1% also, 10% also is a huge drop in the cost. That will obviously increase the margin, the profit of any business. Those tech leads or tech guys, okay, everyone would like to be part of their team, and obviously because you're helping them to have drastic change in the cost expenses. in the tech part. Okay, so obviously they will love to give you high growth. Why not, right? Because you're helping them use money save. Okay, so my point is very simple point it is. Okay, if I say I'm a Linux guys, I'm a network guys, I'm a software engineer, I'm machine learning guys, I'm IoT guys, I'm quantum computer guys, or augmented reality guys, or metaverse guys, whatever say, okay, uh, get the people trained if you are not into AR or VR or maybe cloud, maybe blockchain is not a big deal. Maybe from database guys, I can train you Linux. Why not? I can train you DevOps. Why not? Train someone and use in their right projects might not be big deal. The big deal is the mindset. Is the mindset. So do you have a mindset which your business you're working on, working for, or the project what you're working for, can you help them to give the profit? And believe me, at this point in time, every company is looking for this. FinOps is not a new field, which your tech you are using. Okay, do you have a capability to do some operations? So financial wise, your business will get a profit. That's called cost optimization in the simple term. Okay, if you're able to do this, if you're able to showcase this POC, able to showcase this thing, maybe resume, this is the case study you are working on, this is the POC you have, this is the project you guys work on, this was the previous plan, there's a new architecture, in my new architecture, this is the how much cost we reduce, this is how much performance we increase. Okay, so there will be nothing like this. I can give the bad guys, you will get exponential growth in hike or maybe in the same company. If you propose this, okay, you will have kind of multiple fold X hike. Okay, only this is the mindset you have to keep every time when you're working in the project or in your entire portfolio. Just talk about this, the business profit. That's what it is with respect to your tech stack. Okay, that's the one point. Okay, and I'm just trying to tell you guys around this concept only. Okay, this concept only. So again, time to market, same thing, right? You're doing something very quickly. More quickly you can release, more business you'll get, obviously. More chances you will survive in the industry, more chances you get more customer attracted from your competitors. Or through your competitor clients you can attract. Okay, only thing about the profit. Not for you, for the business. If you give the business the profit, your company, which your guys are working on, you don't need to switch your company. You don't need to switch maybe your current profile, maybe your Windows administrator at this point in time, or maybe the Linux admin at this point in time. What can you do in a current profile to give them profit? Start thinking. Okay, and the answer that you get would be again related to automation and the faster. Example, container, or maybe something like this. That will be, guys, finally look at it. Okay, and that is the reason why, because we have automation here, and because business is looking for profit. So what they're doing, if they have a project where 10 people are working, they're trying to reduce the human being to 2 or 3. There's also one of the challenge why we have a drop in the market of jobs. Why we don't have a job for freshers or the expense guys. Okay, it's hard because we get these jobs for instance Sinji, Accenture, because the reputation what we have, because of the connection what we have. But otherwise, if you go and contact to Accenture guys, by some way you will see there's no job. It's full. Okay. So my point is, they're trying to reduce the cost. They're trying to remove the human beings also, because they think about the business only, right? Okay. For human being is a cost for them. So they want to move to automation, and then the automation they are trying to use a tool they can do the things faster. They are not costly. They are trying to use now more open source tool like Docker or Kubernetes or Prometheus or Grafana and other many other tools also. So they're trying to reduce as much as possible the cost in all the possible way. And that is the reason having a knowledge of good open source tool makes always a great chance in getting better profiles and better packages. Okay, so just I'm trying to give you a lot of guys key components from here and there. We'll connect those components in a minute and then start with the first demo. The first topic with the demo, I will have to start with Docker. Okay, so Docker is a big topic. While I'll show you some of the important part of the Docker. This is the first practical we'll do, and then we will move to Kubernetes. Okay, and after Kubernetes, we'll move to I think some observability tool like Service Mesh HTO. Okay, we'll touch some of the GitHub part. We'll touch then Argo CD. Then we'll touch Grafana, Prometheus, these tools. So these are the plan as a practical in these 2 days. Because Accenture and Sinji is going to ask you in the interview these tools. Okay, and in the last we will connect these tools and create one project. That would be the quick discussion, guys. So let me first complete this diagram. Okay, and then we'll go to Docker. Okay, so let me again go to this diagram to add more components here. So at least you understand, those who are very new in the world of DevOps, they understand what this process look like. Okay, process look like. So again, the things start from idea or the requirement to add new feature in your app. Okay, and then we have a developer. They will develop based on the requirement, the app, by using some language. They build the code. Okay, and mostly it is very common. We always want to put the code in some SCM tool, source code management tool, like GitHub or many other platforms we have in the market. Okay, so my developers keep on, after they write the code, they keep on pushing the code to GitHub. Okay, why? There is multiple reasons. One of the good reason is collab, so other team can collab with this code and they can contribute, they can add new features and facilities and many other reasons also. Okay, then this code is downloaded by some team. Okay, so someone will go and download this code in one of their computer, are called instances or the servers, and what they do here depend upon the requirement. Okay, let's say if this code is written in Java as a language, so you guys know in Java code you can't run directly, so they download this code, it's pull in one of the computer, and here what they do, they take this code and they compile this code, and after compile they create a software that's called package, Java package, mostly the jar file or war file, so we can run this app. Okay, so this process called build. So we have some team who will responsible in building the package. So this is called build server, build environment. We have, and after build, okay, after build, then this package, this package is to be put into one more package. Okay, and that package is here. Let me first tell you one more small thing, those who are a little bit new in the world of Docker. Okay, so in the world of Docker, guys, what we mostly do, we launch the OS with help of Docker technology or container technology, that is within a second. But any OS, whatever launch with the help of Docker, it will launch from the image, this called container image. Some of my team have to first create the images, called custom images of the Docker. Okay, image you can think is like a C drive of Windows, right? So if you want to start the Windows, you need C drive. That's called hard disk or partition. There where you have Windows installed. So you can think customize is most like a C drive, and when you boot the Windows, it will boot from this drive. So you can think in this way. Okay. So in the world of Docker, we need an image, and from the image we launch the OS that's called container. The only good thing is this container they launch within a second, less than a second. But in this OS, what you find the OS, you find the app, you find everything. And whatever you want in this OS, it will come from the image. So every company has a different requirement. So everyone will create their own custom images. It's called Docker or container custom images. So how to create this image, we'll talk about today with the practical. So there's a concept called Docker file. With the help of Docker file, we can create a custom images. Okay, but minimum thing is we need an image, and from the image we can launch the content. Okay, so same thing we will do here. So what we can do, we have some more team, and what they do, they will create a custom image of the container. Let's go Docker, for example. And what they put in this image, okay, what a package they have created Java. Okay, so they take this package of your app, put into the image, and create your new image. This is called Docker or container image. Okay, so this again a kind of build, but here we're building the image. Building the image. Also, we can use one more term called that's called Dockerizing or containerizing our app, Java app or Python app or Node app. That's what the term we use. Okay, and after this image is being created, this image is more like a bootable OS. Then this image we will push and store somewhere. So this becomes some kind of database we have where we are storing all the images, and this database is nothing called registry. So this is a registry of the container images. Now it is your choice. You want to use from public registry or the private registry. For example, if you go to public registry, the famous one is called Docker Hub. That is this one. So your image you can upload here publicly. So everyone over the internet can use it. Your images. Okay. Or you can go for private registry also. So either you can create or you can use some cloud hosting registries. Like in AWS cloud, there's a registry called ECR service, Elastic Container Registry. Azure also they have, and Google Cloud also they have. So these also you can use if you want to use. But these images you have to store somewhere. Okay. Or one more thing we can do, it is also depend upon the further process. Not everyone want to use Docker. Okay, they will like to launch this app directly in your servers. Okay, so in this case, this package of Java we stored in some software management tool that is known as Artifactory tools. And one more term I want to use here. This software is called software or the app or the package, but it's also known as artifact. To store the artifact, we have some tool available in market. One is tool is called Artifactory, one is Nexus, Sonatype, Sonatype, and many more you can find. Okay, so depend. Finally, we have to use the software, but before we use the software, we have to store the software. Store the software somewhere. Okay, so after we store the software, then wherever I want to run the software, maybe if you want to run, then you can run on the top of one Linux OS or Windows OS or Windows Server. So we'll launch one Linux server in bare metal in the cloud on premises and copy this code here, deploy it and run it. So that my client, wherever they are, they can use my app. Okay. Or if he does not want to run the app directly, so what we can do, you can first containerize this app by creating the custom image of the Docker. Then store the Docker image somewhere. And this image you launch. Now, how you launch? Either you can launch directly with the Docker, this is called Docker engine. But nowadays we don't use Docker directly to launch the app. Instead, what we can do, we have something that is known as cluster. That's called Kubernetes cluster. We'll talk a little bit more about the Kubernetes cluster in this topic when I start Kubernetes. Okay. So what we do, we have a Kubernetes cluster running as my production environment, maybe for example. Okay. So what we do, we can ask the Kubernetes, they will go and download this image. They could pull the image and launch as a container on the top of the cluster. Okay, something like this. We will discuss Kubernetes again very detailed, how they work and what is the terminology they use. Okay, they use. Okay, so this is a multiple way we have depend upon different scenarios. Okay, so we'll discuss about this topic. But what I want to tell you here, okay, right now, okay, downloading, understand one thing, downloading the software, only the source code. Let's say step number 1. Then building the package of Java. Okay, so here we can use one tool who help me to automate this part. There's one tool called Maven, if you know. So Maven, M-A-V-N, Maven is a famous tool. What Maven can do, they can get this code, and after getting this code from GitHub, okay, they will build a software with this called package. Okay, now it is your choice. After this package you want to store it in some central tool so that team can download from this. It's like a repository. For repository, you can use Artifactory is a tool to create this repository. or okay, let's say next step would be this one, third. But this package will go somewhere and where some of my team who build the Docker image. Let's say I want to go for this approach. Okay, I don't want to go for this approach for a minute. I don't want. Okay, so someone who will go and build the Docker image. And after build the Docker image, we will push this Docker image to some image database. That's called registry. There's a fifth step. And after the fifth step, okay, we will use Kubernetes cluster, okay, to launch my app. Because I told you guys from the image, we launch a container. So here Kubernetes is the one who will download this image into their area called cluster or their servers. I can say Kubernetes server and launch a container. Container is like complete OS running with your app. So a customer, a client will connect to this container and see the app and use the app. Okay, but right now, the step what I write here from step number 3, then 4, then 5, and then 6. Okay, if you use individual tool or the open source tool or freeware tool, these steps you have to do by yourself. You have to get the software, Docker, and create the custom image. And guys, if you know a little about Docker, that we'll discuss, don't worry if you guys don't know. We can use a concept called Docker file to create a custom image that you have to write by yourself. This is also kind of code. You write and then run on as a fourth step to build the new image or the custom image of the Docker. Okay, then you have to push into registry. And for private registry, mostly we put the image in the private registry because I have my own code. Maybe code contains some password. I don't want to put in the public, guys. Mostly, it's not recommend for multiple security reasons. So to manage your private registry also, then you launch the container. And by the way, guys, container is also not a pod. So in the world of Kubernetes, the container is not a pod. We have to launch the pod. Okay, so these steps, if you're using the individual tool, one tool is called Docker we are using here for building the image. One tool we are using Kubernetes here, that also write in this way, KTS Kubernetes, for launching our container image as a container or as a pod. Okay, so instead we use this individual tool managed by yourself. We can go and use some enterprise tool that is not free, but they can do this entire process automatically. Okay, neither you have to install Kubernetes, neither you have to install Docker, neither to manage Kubernetes, Docker, neither to do this entire process by yourself, neither you have to create your own Docker file also. Everything can be done completely automated. And one of the famous tool is from the Red Hat company that you guys might know. It's called OpenShift. OpenShift. So in the OpenShift, what we can do? Nothing. You have to just tell the GitHub URL. That's all. And tell the OpenShift this is the GitHub URL. Okay. Automatically, OpenShift as a tool from the Red Hat. Okay. That is technically a kind of wrapper of Kubernetes. So behind the scene, they are using Kubernetes. What Kubernetes will talk in some time. As a wrapper of the Kubernetes, means they are using Kubernetes behind the scene, plus some more extra capabilities what Kubernetes does not have. Okay, so what OpenShift will do, they will go to GitHub, download your code, and they understand this code written in Java, written in Python, written in PHP. Accordingly, they will create the Docker file automatically. They run the Docker file, build the image automatically. They'll push the image into OpenShift personal private registry managed by OpenShift. OpenShift, and then they launch the container pod in the OpenShift internal engine of Kubernetes. This entire process, what I'm talking about, is completely automated. And launching the OS is happening with help of Kubernetes behind the scene. They're running inside the OpenShift. And Kubernetes behind the scene uses a container, maybe Docker, for example. And Docker is super fast in launching any container or the pod of the OS. Okay, so what OpenShift is doing, they are giving some intelligence, okay, to creating this code automatically by understanding the code. This code is in which language or which version of the language. Then everything they are doing automatically and in the faster way because they're using container technology. Okay, and that is one of the reasons why we have a huge market of the OpenShift in the multiple companies. Accenture is one of the company. Okay, so technically OpenShift is complete wrapper of Kubernetes. Whatever means OpenShift does not know how to launch the container. OpenShift does not know what I was talking about that point in time. If one of the app goes down, fault happen, how can tolerate the fault, how to relaunch the app automatically. This is done by Kubernetes. Okay, done by Kubernetes. So what OpenShift is doing, OpenShift is a one tool one tool. Okay, we also write in some form OSE, OpenShift Engine. It's one tool, but behind this tool, they have a lot of individual tools inbuilt, and everyone there is specialized in their use cases. So one tool, what they have inbuilt is called Kubernetes. So when I want to launch the OS in the container, OpenShift will use Kubernetes behind this. One thing, they have registry, private registry for the container images. Okay, one thing, they have their own inbuilt monitoring tool like Prometheus Grafana. Okay, and many more things they have. So it's a complete package. Whatever we need to use in complete end-to-end automation, this is what diagram I was trying to create, and it's not yet complete yet. This diagram. So what we need for end-to-end, okay, till after my developer write the code, okay, till my product has been released. Okay, so what you need as end-to-end in the complete automated way or complete faster way, that is what OpenShift provide to you. The tool from Red Hat. Obviously, it's not free. Company has to subscribe this tool depending upon the different licensing scheme they have. This is the tool used heavily in some of the companies, a lot of companies. Okay, we'll talk a little bit more about OpenShift, but for learning the OpenShift, you should be great in Kubernetes. That's what we will learn here. But every concept it's apply on the Kubernetes could apply on OpenShift plus some extra capability what OpenShift gives. Okay, and why I'm discussing OpenShift here, because in Sinji they don't ask you OpenShift, but in Accenture interview they will definitely ask you about the OpenShift. You should have some understanding of the OpenShift. That is what I'm trying to touch some of the term. Otherwise, we'll see more concept and demos of OpenShift also as we go ahead. Okay, and that's what I want to add. So this diagram is very big actually. We just started. We just started. Okay, so let me go more deep into this diagram. So let's forget about the OpenShift for a minute. I just want to introduce some term. Okay, let's say we again we'll start from here, from the requirement. My developer write the code, they push the code in GitHub. In the GitHub. Okay, and then we download in from my team called build team. In the build environment, we build the code. If it is Java, then we can use Maven command. If it is a Node, then we have npm command to build. Okay, and many other tools available depend upon the programming languages. Okay, and after build, we will create the custom image using Docker file, and this custom image will store into registry, public or private, it depends. Okay, but after this, we never launch the image directly into our process environment. We'll do after some part. This we don't do. I just wanted to explain you the remaining part. So that's what I give in this diagram. But technically, after this image create, what we do, we will launch this image in some of my testing environment. So we create one more environment that's called testing environment. And mostly this testing environment you can launch purely with Docker engine. So we're only running Docker engine, because to run any image we need Docker engine like a Docker program or Docker server. So we download this image full, and this image is a custom image, and we launch this image on the top of this guy as a container, as an OS. And why we are doing so? Because I would test something. And what you want to test? So there will be many things we can test depend upon the situation. One of the things we can test is, let's say there's an app Okay, so I want to check all the functionalities of the app. App is more like, let's say this is a web app. This is a web app. So my button is working or not, my chat button is working or not, my login button is working or not. All the UI part I can test. This is one of the things we can test. Okay, because without testing, I don't want to launch my app to the production environment, right? And for testing the UI part, okay, this is one of the testing we can do. So for this, we have a different tool available in the market. Let's say Selenium is one tool available in the market. Then we can test about a lot of security things. Security things. Okay, any security vulnerabilities. Okay, so a lot of security vulnerabilities we can test by having multiple different tools of security vulnerability checking. Okay, or we can test one more thing, because I'm launching this container from the image. Okay, from the image, but there's a possibility the image what you're using, what you have created, this was the image we created. Okay, OpenShift will create automatically, but in our case, without OpenShift, you have to create this image by yourself by Docker file. By Docker file. Okay, and that's one thing, guys. Normally in the interviews, they are not asking you, okay, to go for demos. Even though I'll show the demo to make you comfortable with this concept, but interview is mostly interview, right? Or technical interview. So you should be conceptually right and conceptually strong in different stages and different tools. Okay, so that's what I am trying to, because if I start demoing, every tool is a big tool. It takes a lot of time. Even though I'll show a lot of demos of Docker and Kubernetes and Prometheus and Grafana, or Stio maybe, or Argo CD maybe. But right now, my main emphasis would be to give you a lot of knowledge base and a lot of vocabulary also. Okay, and also architecture, the flow, how the thing work. Okay. So the image, whatever you create, there's a possibility this image also have some vulnerabilities. So we have a lot of image scanning tool available in the market. This is called container image scanning tools. Container in the market. Okay, one of the famous name in the market for this tool is called Trivy. It's a very famous tool. Okay, so Trivy is one tool. What they can do, they can scan the container. So if you search for container scaling tool, Trivy. Okay, image scanning. They can scan the image and they'll tell you all the possibility vulnerabilities in this image. So technically, before we launch the container in the Kubernetes in the production environment, we first test the image by scanning tool. Does they have any vulnerabilities? Okay, and what you find, guys, mostly you'll find there will be vulnerability due to XYZ reason. There are a lot of big reasons, guys, where okay, where you can use this. And Trivy is not the only tool. There's many more tools available in the market. Docker also have their own inbuilt tool. This is called Docker Scout. That's also we can use. But guys, in the world of security and the vulnerability, it is a game of how much vulnerability database you are maintaining. This is called CVE database. Okay, common vulnerability and the exposures. This is a kind of database where some company maintaining. So Trivy is a huge database CVE. More information they have about vulnerability, better answer they can give while scanning. So Trivy is a great tool in that context. Docker Scout also good. You can use this, and many other tools also available. Okay, and these tools are kind of automation tool also. You just tell the image name and tell the vulnerability severity level. So your vulnerability is critical or high or warning level or low level. So based upon their requirement, they will quickly give you the report. And based on the report, you can take the action. You can think there's no vulnerability, then you can go for further action. You can take this image to your production environment, maybe in the Kubernetes to launch. But if you have a vulnerability by scanning as a critical vulnerability, obviously you can't launch this image in your production environment here in the Kubernetes. In this case, what you have to do? Okay, so they will tell you the report which part you have the vulnerability. So there's a possibility this vulnerability come from my developer who write the code. Okay, and Trivy does not check the code for the vulnerability. They only check the upper layer. What do I mean by upper layer? So when I go for this topic or Docker file, then I talk about the layers. Okay, so Trivy will check that you are using some Java runtime engine. Okay, and this Dockerfile, there's a concept called base images. You use some base images or some other syntax issues, not syntax, I can say some other key factor that will give you the vulnerabilities. So wherever you have the vulnerability, you have to go back, use a different version of the Java, use a different version of the base images, what you use in Dockerfile. We'll see when we learn this topic, Dockerfile with the practical. Okay, so the one who is responsible for creating Dockerfile, they will go and change something here. And again, this process will repeat. Again, they build a new image with a new change, new version. Again, they push to the registry. Again, we download. After download, we do all the testing. Okay, because something changed. Maybe this time my UI is not working. Maybe this time we have different security vulnerability. In scanning, we have different image related vulnerability gonna come up. Again, we test. So test is one thing that you have to keep on doing again and again and again. And this I'm talking about just one of the part of testing. We can do testing on the code. Code means the code that is developed by developer. Developer means my developer write the code, they put the code in GitHub. Okay, but before we build the package, my app, okay, mostly we have one more layer in between here. So we have one more server. So a code will download first here, and these guys will do some testing. Because here this is my raw code. My code is not been compiled. My package is not yet created. So first we download the code, pull the code over here in this computer, and this computer will do some testing on the code. And what they test? They test that my code has some kind of vulnerabilities. Code has directly. And mostly, if you guys know, whenever you write a code, in the code, everything we write as a functions, like in programming language functions. Okay, and every function is doing something in your app. One function is, let's say this is a VLC player. So one function is play function, one is post function, one is image video streaming function. Everything is function, right? So mostly with every function, we write some test cases. That's called unit test cases. Okay. So if it's code written in Python, then we use PyUnit test or PyTest framework. If it's Java, then we use JUnit framework. Depending upon the language to language, we have a different unit test framework. Unit means nothing, functions, testing. Okay. So we have a lot of testing here. So we have a tool who will check are your entire code we are testing or not, because the app is very big, hundreds and thousands of functions we have in one app. Are we testing every functions? Because good practice to test every functions. There's a concept called code coverage concept. So are we covering the entire code for testing? Or my code has any vulnerabilities with the bug? So that's also we can do. And after we test everything, if something worked fine, then we'll ask my next team, now this code is working fine. We have no code vulnerabilities. We are testing every part of the code by writing some unit test. Okay, now it is good time to create a package and use this package somewhere as an app. Okay, so for this also we have a tool available. One of the famous tool called Sonar Cube for this. So if you search for Sonar Cube, okay, so they check about common standard, they check about vulnerabilities, they check about the code coverages, and many things okay, about the code. Okay, so that could be used. So if you notice, guys, if you notice here, my developer start the code, we put in the GitHub, then we download the code, we asking the Sonar Cube, take this code, check the vulnerabilities we have in this code. If yes, then tell me what is the vulnerability could be, so I can ask my developer again to rewrite my code with a new version. Again, my developer upload the code, my Sonar Cube again check. If there's no further vulnerability found in my code, or my code coverage also good, then we ask this code to be used by build team. Okay, build team will build the image, so build the packages. This package will go to my Docker team. Docker team will create the new custom image, and this custom image we will send to my storage. Then it go to Docker engine. Then because this final app has been created, okay, my app launch. But this app launch, I launch in my testing environment running by the Docker. You can use again Kubernetes also here. Why not? Because you're going to launch a container from the image. So launch the container, we can use Kubernetes, we can use OpenShift, we can use pure only Docker, no Kubernetes, no OpenShift, depend upon multiple scenarios. Okay, as a testing environment. And after my app run, we can do many more testing, my app feature, UI working or not. Okay, or the image, whatever launching have some vulnerabilities or not. So we have different tools, Selenium or Trivy and Docker Scout, and many more tools available for different testing. If everything working fine, then this image that I tested completely, I will again push to one of my different registry. Okay, maybe let's say AWS ECR registry or some other registry to keep my image there. And this is the location. Okay, this registry we specially meant from a production environment, and we write in the registry as soon as new image come into this registry. This new image means something new code gonna come up, new image gonna come up, new version of my app gonna come up. Contact to Kubernetes. Okay, that is running in my production environment somewhere. And ask them that you might be running with the older version of my app, let's say V1. Now we come with a new feature with the version called V2, and we go to all the steps, what's called stages in between. We test, we scan, we rectify all the vulnerabilities. Okay, and we are asking now, okay, the whatever version you have V1, now we are coming new version, new feature. I want to release the new version. This concept called roll out to the market. Okay, so here this V2 version will be replaced, V1 version will be replaced by V2. And because this is Kubernetes running in a production environment, so this is a system where my client or internet guys is connecting. So when the next client connect to my app, they will see the new feature, new look and feel of my app. But if you want to roll out a new version or release the new version, okay, you can't just change from V1 to V2, just remove the OS and relaunch the new. It is not the right way. So whenever you roll out a new version, it's called deployment of a new version. So we have a lot of deployment strategies to be used. Okay, so guys, you might heard about one of the strategy could be A/B testing you can use. One of the strategy could be rolling update you can use. One of the strategy could be canary release you can use. One strategy could be blue-green deployment you can use. Okay, and many more. Depend upon the scenario to scenario. Okay, but technically, because we are launching my new version, replacing with the old version. Why new version? Because I told you it is not only that you are start from first, but after app launch, we keep on changing the new feature, new look and feel, or we'll keep on fixing the vulnerability and the bugs. Okay, so almost every day 10 times, so week 100 times. Okay, in a big organization, they keep on developing the new code and new features in a day 10 times or 100 times and week 1000 times. Okay, so it is very common. New versions keep on coming up, but replacing the version, because why to replace? Obviously, I want to show the client a new site with improved features, so improved bugs and vulnerabilities, or new extra add-ons. Okay, we can directly deploy. Okay, we have to use some strategies. Okay, because we are deploying on the top of Kubernetes, so Kubernetes have an inbuilt support of these strategies. Okay, so I can ask Kubernetes, can you please help me to deploy version 1 to version 2? Let's go roll out new version. So you can say I can do for you, and but you have to tell the Kubernetes with strategy you would like to use. Okay, so if you are looking for rolling update strategy, that what is this? We'll discuss when I talk about the Kubernetes practicals. So can you say yes, I support this strategy? Okay, but if you ask Kubernetes, no, I want canary release or blue-green deployment. Okay, so Kubernetes again does not have the native support of this guy. Kubernetes is technically a big tool, very powerful tool, but not everything they support based upon your custom requirement. Okay, so when I want to deploy something, a new version, okay, depend upon scenario. We'll talk about the scenario in very detail, but Kubernetes does not support all the scenarios and all the strategies. So what you have to do, okay, on the top of Kubernetes, you have to add one more extension, extra support on the top of Kubernetes to support canary release or blue-green deployment, or maybe A/B testing. Okay, so for this again, multiple tool available that will work with the Kubernetes or as an extension of the Kubernetes. Okay, one of the famous tools is called Istio Service Mesh. Istio Service Mesh. Okay, so if you want in the Kubernetes to do canary release, for example, So if you ask Kubernetes, do you have any keyword for this, support for this? They said no. Blue-green deployment, they said no. A/B testing, they said no. Only strategy what Kubernetes support is rolling update. There's one more strategy called recreate strategy. What are those? We'll discuss. The two things that Kubernetes support natively. Do some kind of manipulation, but it's not the proper way. Right way to do is using some extra tool on the top of Kubernetes. In this case, called Istio Service Mesh. Okay, that's what we can use. Plus, if you go for Istio Service Mesh tool, they will give you many more things to be controlled that we'll discuss in some time. Okay, you know the things that I was talking about the initially. Okay, it is the visibility. So Kubernetes does not give you capability if you launch any microservice in the top of Kubernetes, because if you see here, service, post, chat is different app. All that will run as a Docker image by creating custom Docker image. Okay, but this custom Docker image will launch on the top of Kubernetes. So technically, the entire microservice architecture is run on the top of Kubernetes. But how they connected, how the traffic is flowing, which is down, how much time is consuming, Kubernetes does not give this entire observability. Okay, so that without observability or visibility, I can't go for root cause analysis. That's what I started. Okay, so here service mesh will give this capability. So they will monitor every part of the network packet flow by the Istio service mesh. So they have the entire visibility what is going on. Okay, to show you the entire. So we can go more deep into this to troubleshoot. And that tool is called Kiali. So Kiali is a tool, is a graphical tool, visual tool. Kiali. Okay. And it will show you this kind of visibility of your microservices. Okay. So if you see this diagram, you can see like very clear, right? So this is one of my app, this is one of my app, this is one of my app. So I can see my packet is going from this direction to that direction. Between this, how many requests we go on, what is the latency we have. So Kiali is a graphical way to visualize things, but behind the scene, this information is provided by Istio Service Mesh, and Istio Service Mesh is running on the top of Kubernetes. App is running. Okay. So here, with the help of Kiali and the Istio Service Mesh, we have a observability. Okay, and if some of the app is goes down, they can say the red mark here. I know this app is goes down. If some app is taking a lot of time, so there's some kind of red mark gonna come up, or they can say that latency time, how much time they're taking, and many things we can do on top of this topology. And this topology is called mesh. Mesh of multiple services, a microservices. This is called service mesh. Okay, so that's what Kali can be used full for this. Okay, and guys, there will be many more tools I can add and add and add. But point is, the point is, the process what I'm talking about here, this one, this one. So from the idea or coming the new requirement or new feature, from the development to the release, the lot of multiple step known as stages come in between, and you have to follow all the stages, mostly all the stages depend upon the requirement. Okay, I can't bypass security checking, I can't bypass building of the image, I can't bypass creating the package, I can't bypass the testing of my UI. Okay, And there were many more different testing: load testing, stress testing, integration testing, unit testing, many things there. After we go to all the passes stages, then we deploy the app. Okay, and this entire concept is called pipeline. Is called end-to-end pipeline. I have to use. Where this pipeline is divided in two parts. That again we'll discuss in a minute. One part is called continuous integration, and second part is called continuous deployment, also known as CI/CD pipeline. Okay, now this pipeline, whatever you're using, okay, are you're doing manual. You can use manual, why not? But I told you manual will slow down things. So whatever we're doing to checking security, for example, after my image create of the Docker, okay, image of the Docker created, and before we launch this image in my production environment in lesson Kubernetes, I can check my image vulnerability by Trivy tool, okay, or many other security tools in the automated way. It means now all the security tasks we can check automatically. And there's also some concept also, guys, the remediation also. If you find some security issues, we can automatically solve also. It's called remediate. There's also some capability tools available in the market to remediate, means to resolve any security issues in somewhere in automated way. That also we can do in most of the cases. It's called remediation. Okay, so the point is, whatever you do in the world of security, that can also be automated, and this is called DevSecOps. So as a DevSecOps engineer, okay, what you think, whatever you're doing and wherever you're doing with respect to security, okay, can be automated. Rather we can do it manual, we can automate. Because I told you, if you do anything manual, it will slow down the things. There's chances you might miss something. But if you automate, things will be done very, very quickly. So we have a lot of DevSecOps tool come up that we can do all the security things in the automated way. So if your mindset is automation and doing everything as automate, then we can use the word called DevOps. Okay, means whatever and wherever we're using in this entire pipeline, this is what the entire pipeline from here, one by one. If you see here, multiple stages we have, we call pipeline. In every pipeline, in every stages, okay, can we do that particular stage part in automated way? Can we take the right decision in automated way? Okay, then we can say we are the DevOps engineer, because we're thinking in every part of my stage, of my pipeline stage in the automate. But at the same time, we're also thinking whatever we're doing, it will be quick and faster. So one of the way we can use, wherever we can use Docker or container tool to do something, we can use. Okay, but one more time I want to give you here is, if this diagram, what I was talking about, if I try to create a little bit more clear or smaller, even though this diagram is still not complete, guys, there were many things to become in between, but I'll try to give you a kind of sophisticated diagram to tell you at least these are the kind of minimum thing to be there in any good pipeline. Okay, from software development to the release. This is also mostly known as SDLC, software development lifecycle. Okay. So if you make this diagram a little bit more clear, or not clear, I can say smaller, to give you some more terminology and the vocabulary. So again, from the requirement, it come to my developer write the code, they push the code to GitHub, and this code is been downloaded by my build team who build the app if it's written in Java or kind of language. Okay, after build, we test my app. After run the app, everything working fine or not, and you will see it's a very high chance when you test multiple thing, you test everything what you test is called test cases. We test multiple test cases, mostly test case fail. And what test case fail, we will give back the report as a feedback to my developer. Hey, this is the part is failed. So my developer again rewrite the code to rectify the issue. Again, they push the code to SCM. Again, we download the code in my build system. We rebuild the new package. Again, we test. Again, they fail in some other reasons. Again, we send back the feedback or report to my developer as a test report. Again, they fix this bug or fix these challenges. And they push. So this again, this cycle is keep on going on. It's called continuous. In this continuous, this is called continuous development. Okay, and SM tool we use for collab. This is called continuous collaboration. This is called continuous building. This is called continuous testing. Okay, and here all the tools connect together, integrate together in doing this part what I'm talking about, and this is called continuous integration. There were many more tools coming in between, like code coverage, like Sonar, Cube, things that I was talking about. But let's say these are the minimum thing I'm talking about right now. So this concept is called continuous integration. Now it is your choice. This part you want to do it manual. This is called manual continuous integration. If you want to do this thing automated way, then we have a lot of automation continuous integration tool available in the market. One of the famous one you might know is called Jenkins. So what Jenkins can do? Jenkins will download this code for you automatically. They build the code automatically. They test the thing automatically. They resend back the report to developer automatically. So everything to be completely automated. So if you want your continuous integration to be done in the automated way, this is called CI automation, and we can use Jenkins as a tool. It's automation server for build test and other things. We can use, right? But this side, what you're talking about is only the developer perspective. But after testing completed and successful, so at this stage, if testing is completed, okay, then what I want my code to be deployed in the production environment. So this code after tested will take to the production environment, will run it. That's called deploy. So my client can able to use and see my app. See my app. Okay, but after you deploy in the production environment, typically, if you are the big MNC, you are a global company, you have multiple clients in multiple countries, multiple cities, multiple regions. The good practice is whenever you deploy your code, okay, it's called release. You don't release your code everywhere, every part of the world. Okay, let's say out of 100, okay, only 1% or less than 1% or 0.1% customer you release your new code, because we never know. We test everything, we are happy with our code and idea or new feature, maybe client won't be happy. They don't like this new look and feel. So we release a very small set of real customer, so that for out of those 1% customer, less than 1% customer, we take the feedback. Sometimes you see some app, they will give pop-up. and they ask you the feedback. So you ask few customer who this company is showing you their new app. Okay, if you feel, if your customer, real customer is giving the right feedback, if they're happy with this app, then slowly they increase the number 2%, 20%, 50%, 100%. So they don't release complete app together. Means, let's say initially out of 100%, 99% they are still showing the last version of the app, let's say V1, last version, and 1% of the customer they are showing new version of the app, V2 for example. And they keep on collecting the feedback from the customer, the performance, from the performance tool, and many other things also. And slowly, if they're happy, they are decreasing this number of old version, increasing this number of new version. This release called canary release, guys. So mostly in all the big releases or major releases, it is good practice to have the canary release. Okay, because we think it is a good idea, we think it's good marketing plan, we think it's good look and feel, but we does not know what customer is thinking about. I can't take a risk to show my entire app to entire customer. It would be big issue in terms of business loss and the reputation also. So start with smaller chunk and slowly increase the traffic. Okay, so that's called canary release. But for this, okay, we keep on monitoring by a lot of monitoring tools also. Maybe new version might have some issue in some performance issue, so we can use some APM tools, application performance monitoring tool. They keep on monitoring the performance of my applications. Okay, and from this report again, we send back the report to other team, and the team will send to developer and say your code have in this function, we are doing some database connectivity, there's some issue in the connections closing, so can you rewrite the code to fix this issue? That we can monitor from APM tool. And some of the very powerful APM tool you might know is App Dynamics, AppD, New Relic, Datadog, Relic, Datadog, and many more tools available in the market that they can use. Okay, meanwhile, by launching the app to the production environment, still we keep on monitoring. Okay, and we still will see a space to improve my app. That's what we always have. And again, we will send back to developer again write the code. Again, they push the code. Again, we build. Again, we test. The testing might have bug. This circle of CI will go on, and finally, the testing will be done. New version with update version of performance, and the bug will be released. That's a V3. Again, the V3 we do canary release. Okay, and same process going on. So technically, what we are doing here, we are doing continuous deployment. CD part here. Okay, so technically, we see from the developer while launching your product, we have CI/CD is happening because CI/CD pipeline is happening. So this is a smaller architecture in terms of look and feel. The bigger architecture, if you see, this is what I was talking about. Okay, there's a lot of things come in between. So I'll try to create a small diagram to give you this vocabulary. Now, if your production environment is running with Kubernetes, okay, to launch your app as a container or as a code, so Kubernetes does not support canary release, because the canary release, we have to shift the traffic slowly. We have to run two versions together, and slowly we have to shift the traffic to version 2, 1%, 2%, 3%, so on. So Kubernetes does not support this, and that is a reason we have to add some extension in the Kubernetes called service mesh. And for service mesh, we have a tool called Istio. So it's a tool who can give the capability of service mesh. And one thing that service mesh support is this capability of traffic shifting that we use in the canary release. Okay, so that's how it works. But the point is, CI is done by Jenkins mostly. Some cases, okay, I can say till date, we are still using Jenkins CD part also. So Jenkins is the one who will contact to Kubernetes and say, hey, new version gonna come up, you have to relaunch and release or roll out. So we can use Jenkins also for CD part. Okay, but nowadays there's some methodology will change. Okay, if you're using Kubernetes or kind of environment, you're using Jenkins for CI, a CD part also on continuous delivery also. Sometimes it's a continuous deployment, continuous delivery. There's some more change difference, but let's say nowadays, if you want continuous deployment, okay, so we use a concept called, I will talk a little bit about in some time. There's a concept called GitOps. So the GitOps principles we have, it's not tool, it is a concept, it's a principle, it's a methodology. And according to GitOps, we have to control everything from the GitHub. Means I want my GitHub to be one single source of truth. Means if I have any code here, okay, if I change some code directly in my GitHub, and as soon as I change my code in the GitHub, automatically my code will be deployed in Kubernetes or some other tools. So I don't want to use neither Jenkins, and Git also have guys the concept of Git actions. I don't want to use Git actions or GitLab. None of this tool, just pure SCM tool. Anything change in the SCM, this is my GitHub, my operations part will be automatically happen. Operation means my code will be run in my production system. This is one of the part of operations. Okay, so what I mean by this, what you see in the left side is mostly the role of the developers. They are the one who write the code, manage the code. Sometimes they also build the code and many things. And what you see in this side, to launch this server, deploy the code, monitor the code, the app or the server, that is a part of the operations team, and that's called DevOps. Now, whatever developer is doing, what operations team can doing, if we can, mostly we have two different teams. There's called silos. They have no further connectivity. There are two different teams. But if you want complete automate, so we have to remove the silos in between. Okay, we have to give better visibility in between teams so that we can do end-to-end automation. So the approach where we can remove the silos between team and can do complete automation end-to-end means after testing done, automatically my operation team come to know that has been done. Testing is done. We have a test case pass. So my CD kick in and my app will be launched automatically. Rather than they wait for the development team or the option team, they will talk to each other and they do the things, right? They will done automatically. So DevOps say, you're an engineer, either you can work with both the teams together or individual team. So what your approach would be as a DevOps engineer, the entire end-to-end pipeline, I don't want any human intervention. Neither option team can wait for dev team wait for option team. They collab, does not collab, does not matter. I want my entire automation to be end-to-end to be done automated. That's what the word DevOps as a term comes from. Okay, but nowadays DevOps is a kind of the pretty standard in the market, and the improvised model of DevOps is GitOps. Okay. And according to GitOps, okay, now I want everything to be controlled by GitHub or Git tool. Okay, for example, if I change some code here, as soon as code change, automatically, just for example, my deployment tool where I'm deploying, let's say Kubernetes, in my case, for example, come to know something will change. So Kubernetes will automatically go to my GitHub and get the new code and relaunch by some strategy, whatever strategy you use. Okay. So previously, if you just talk about Kubernetes, so Jenkins is the one who contact to Kubernetes and do the continuous delivery. Now we don't use Jenkins. We use some other tool for a lot of reasons. I'll tell when I do the demos, those reasons. So we use a tool called Argo CD or Flux CD or many other tools available in the market to do the continuous deployment that work completely with the principle of GitOps. Is again big concept to be discussed. When I go for demo, I will make you understand that point in time what is GitOps is and what is Argo CD as a tool can do for you. Okay, so now your CI part will be done by Jenkins or Jenkins kind of tool. It could be TeamCity, it could be Bamboo, it could be Circle CI. But CD part, okay, is to be done by some CD tool that use a continuous delivery or GitOps principle. This tool is dedicated for Kubernetes, but if you use some other environment, they have different tools. But if you're using Kubernetes for deployment part, okay, when I say deployment, you can say delivery also. There's small difference, but same thing. CD means continuous delivery or continuous deployment. Okay, so Argo CD is the one who can use. This is a look and feel of the Argo CD, and many more things we can do with this guy. Okay, so when I say CI/CD, that means end-to-end pipeline, and I want everything pipeline to be done automated way. We don't want to depend on any one. Everything to be automated and faster. That's what DevOps principle is: rapid, fast, and automate. Okay, but for this, the left side there's more aligned toward the developer. Could be done by CI tools like Jenkins, and right side that is more aligned toward operations team. I want this part to be also automate. The CD part, then by a tool called Argo CD. I am not saying you can't do with Jenkins. Till date we are using with Jenkins only, or Jenkins kind of tool. But now we love GitOps concepts, and I want to use GitOps. Then, if you want to use GitOps principle, then Jenkins won't help you. Jenkins does not work as such with this core principle of GitOps. So, if you have to use a tool that work with the principle of GitOps, in my case, Argo CD could be the tool. Okay, so guys, this is a high level concept. So right now, guys, I know I keep on speaking from last couple of hours. Okay, my plan is to give you a lot of these vocabularies. Okay, and the concept of individual tools and this pipeline and some of the terminology. I try, guys, my best, because I think now you understand DevOps is a big world. Only Docker, it takes a lot of days to complete. Only Kubernetes, only Argo CD, only SonarQube, only Trivy or DevSecOps or GitHub. There's an individual tool for individual requirement. But right now, in the interview of Sinji or Accenture, okay, if you know the concept, if you know this pipeline, if you know where this tool has been arranged, that give you confidence. Okay, and mainly your interview would be around Kubernetes and the Docker and something of Grafana, Prometheus. Okay, so those two I will go more deep with practical hands-on. Okay, but this concept I just want to explain you, because during the interview, obviously, they will talk about the projects, they will talk about the pipeline, CI/CD. They use multiple terminology. So you should know, and you should be comfortable with this terminology and where that stage fit in this diagram. That is the only intention why I take this extra time to give you so much information here. Okay, but after this, completely everything is completely hands-on and the practical. Okay, and the first topic what I'm going to start, obviously I'll go for Q&A right now, then we go for lunch break. Then the first topic with the practical that we are going to start is Docker. We'll see a lot of interesting practical with Docker, then we move to Kubernetes. So today my plan is to touch these two topics practically. As much as deep we can go, we'll go. And tomorrow we'll go more deep in Kubernetes with using multiple deployment strategy like service mesh, Steward, candidate release, then Prometheus and Grafana. So this is the quick plan for next topic, and those will be completely hands-on and practical. And don't worry, most of the part what I explained to you during the practical, I will relate again, so you can very quickly sync with the concepts. Okay, now I'll take a pause here. Any queries if you have till now, you guys can ask me. And before the lunch break, we have a one quick recap. I can say not recap, is an assessment. So let's say we'll do maybe after the lunch break also, but team will update, because based on the content what I cover, we have a one quiz kind of assessment. It will quickly revise the concept and plus also give you quick idea about at what level you are at this point in time in this concept. Okay, so, Dilip, if you're listening to me, please ping me how we and when we can do this quiz. I think is ready, but if you can tell me by the way, if you have, you guys tell me. Can interview based on Docker and Kubernetes? Mostly, such a will based on Kubernetes in both the company. Most of the part, I can say 80-90% part. Remaining part would be Prometheus, Grafana, Docker, and maybe something related with these tools. Okay, so like maybe service mesh, Steward, or Argo City. Okay. So we have multiple job location, Tahir. So some could be in Jaipur, some could be in Bengaluru, or maybe in some NCR or Hyderabad. Okay, and the job is purely DevOps engineers or SRE guys. So it's a good role. I can say this is a very sophisticated role to be worked for. I belong to health is IT domain with 2 experience. I'm ready for DevOps job after doing this. Not it all depend, Vishal. Just by saying you're from IT, health IT domain. So which tool set you work till date? Okay. So if you work in the same tool set, what I'm talking about right now, so it will be more like a hike you're looking for at this point in time. Or if you're not from same domain, then it could be job switch. Okay, so this 2 days we are preparing you for both the cases, for job switch also and for the hike. Okay. So I joined 1.5 hour late due to power issues. Actually, Surajit, we covered a lot already. I'll try maybe during my practicals, most of the part will be again recovered. So I think that will be time you can have a quick look what we cover. So if you build in tool in ACR, yes, actually, Pankaj, you are right. A lot of content registry, they have their own built-in tool for image scanning. Okay, example, in Docker we have Scout, Docker Hub, I can say. In ECR you have Claire. So there's a lot of built-in scanning tool available in your registries. But the point is, we might not be comfortable to use these registries. Maybe I don't want to use ECR. I want to use my own private registry. Okay, because I have an image that contains some sensitive code and data. I can't put in ECR in AWS Cloud and either Docker Hub. I want to create my own private registry. Then how can I scan? So we need some tool who can run locally. And second thing, Trivy is not only for scanning, okay, because mostly we run our thing in Kubernetes. Kubernetes is like a program, and Kubernetes also have their own configuration. So Trivy will help you to scan the entire Kubernetes infrastructure and the configurations. They also tell you we have some kind of misconfiguration and the bug in Kubernetes and their configurations and best practices. Okay, so that we can do. We can't do with ECR because ECR is not Kubernetes. And if you know AWS, we have EKS service of Kubernetes that does not give you all the configurations because they run manage the master node by themselves. Okay, so that is one point. How prevalent in the use of AI and DevOps currently is this use actually is now is growing. Okay, nowadays DevOps itself is taking away a lot of jobs. I told you already. So whatever we used to done by 10 engineers in one project, okay, now because of the automation, it might decrease down to 5 engineers or 2 engineers. So they're also taking away a lot of jobs. But now what is happening? Now what is happening? We have generative AI. Okay. And now what this 2 engineer DevOps was doing can be done by 1 engineer who knows generative AI with DevOps. So now, right now it is not on the main front line, but you will see in some months, okay, the task that is been done by a DevOps engineer. Okay, because DevOps guys, if you know a little bit Jenkins or Terraform or Ansible or Kubernetes, here you have to write a code in the respective tool. Like Docker, we have Docker file. In Kubernetes, we have YAML file. In Ansible, we have to create a playbook. In Terraform, we have to create a manifest file. Okay, every DevOps tool is automation tool, and for automation, we have to write a code in their respective language that is very simple to learn. Nothing called pure programming language, very simple language, but something we have to write. Till date, it has been developed by the DevOps engineer, let's say of Ansible, let's say of Docker, let's say of Kubernetes. Now, because of generative AI, this code to be written automatically by writing the prompt. So, idea is very simple. You just tell the prompt, hey, this is my use case, and they write the entire code. And not only code, they also implement the entire setup. The entire end-to-end that I was talking about is completely created and operated with a concept called Gen AI Ops. Gen AI Ops. So it's very, very dangerous actually in the terms of job. So out of 10 guys, what I have in one project, now one guy is enough who know Gen AI Ops setup and who can do the things completely automated. So that's very dangerous for human being for the future job perspective. But this is possible. And even though guys, I had delivered one interesting training on Gen AI Ops, where entire part is just by completely created and implemented with the Gen AI. So I deliver one very quick training, custom training for this, even though this one training I also hosted in Udemy. Anyone who want to learn this with a complete practical. So if you go to Udemy, recently I launched one program. If you search my name, Vimal Daga in Udemy. So we were not there in the Udemy guys from last couple of week. We hosted 4 different courses. Okay. And one of course, now the course is kind of great rating in just a couple of weeks. So this is the course. Okay. AI powered DevOps, where all the tool, all the tool, what we use in CI/CD and the world of DevOps, I'll show here with a complete practical with a lot of AI tools like Kubernete GPT or many other tools to be integrated, and how to create an entire CI/CD with just by prompt. And not only creating code, this code has also been implemented. It's a very fantastic content, complete hands-on. So anyone who want to learn, you can go and learn from here. Somebody asking, that's what I'm quickly want to share with this information to you. Okay. And now is the world of prompt ops. It's not prompt engineering, it's prompt ops. My entire operations could be done just by prompt of GPT. Okay. So that could be work. Is this job available in Kolkata? Soumya, right now, this 2 job what I'm talking about is not in Kolkata. But I told you we keep on having multiple company. The content what I'm delivering here could be a common from other future companies also. Maybe some company might be come for Kolkata. For example, PwC. We have sometime recommended PwC. So I think they mostly sometime ask at the Kolkata region. But right now, this tool is not for Kolkata, at least I know. Can fresher continue this class? Actually, for freshers, we have already run these 2 batches already. So we had job in Deloitte. We run one batch for Deloitte for freshers and one for Sinchi again for fresher. This is not for fresher. If you want to learn for learning perspective, you can sit here, no issues. Okay. But the job opening, what we have for this program in Accenture and Sinchi, it is not freshers, not for freshers. But we have a huge opening, and we already have a list of company with us already coming in April and May for the freshers. And I think we have started one job preparation program on this 22nd for the upcoming companies, and that is coming in April and May month for the freshers. So we have 18 company that is already been given their requirement to us for the DevOps role and SRE role for the freshers. And I think this is also one initiative we launched. So if you're a fresher, you can join that initiative. Yes, anyone? I'm Accenture in non-DevOps role. So Sumit, it would be if you already in the Accenture, then I think that would be a great possibility. Okay, that help you in switching your role. So we'll help you. So just complete this 2 days and ping to my team with this note that you're already in the Accenture. Okay, so we'll push your resume because that will be higher chance based upon what you current expertise on at this point in time to give the job role DevOps like a switch in the same company. So how much DevOps concept we need to know in technical job? Actually, DevOps big word. I think by looking at this diagram, what I was talking about, you come to know come to know that there's a lot of tool I talk today very, very quickly. They will make some more tool, and every tool is itself a one complete program. So it's a big. Even though I have my own course on DevOps, there's a 3 to 400 hours where I talk about these courses or these tools, very detailed and practical, with a lot of projects we prepare there. So it's a big world. But right now, this was Sandeep you asking me. Right now, I'm preparing you only what could be asked in Accenture or Syngene. So we took the requirement. We have a lot of our student who working there. I know what they ask you in the interview at this level of a role. Okay, so only those concepts and those vocabulary and those practical we are delivering here, so that you can easily crack the interview. So I am certified OpenShift and Kubernetes. Okay, so if you have certificate, that will always give you extra benefit, obviously. So if you have, that's nice. Yes, polyglot is just a concept, Mohammed. If you have one app, mostly the microservice written in multiple languages, then it is concept called polyglot. Yes, Kuldeep, the preparation we are doing for experienced guys. So minimum you should have experience 1 year and so on. 1 year, 2 year, 5 year, and 10, 20 years also. We are also trying to help those guys. But mostly this is for the experience of 1 year to 4 to 5 years, mostly. Okay. SonarQube and Trivy look like same, but they're different tool. SonarQube is mostly checking the vulnerability in the app code, let's say written in Java or Python. Okay. Plus they also do code coverage. Trivy is a different tool. They are finding the vulnerability on the image, the container images, like Docker images. Okay. So there's a big difference right now. Yes, Raj, we will go through one project. That's also we implement also in this training by implementing multiple these tools. What we was talking about here. So most of the tool what I was showing you in the diagram, we will implement it. Okay, and create one project. Yes, Sudhir, you can scan the entire cluster with Trivy. So they have capability of scanning the entire cluster of Kubernetes. So, Arun, I am working in Accenture. I completed cloud certificate recently. I have good progress my comparison tool, testing team, batch processing, hands-on cell scripting. Yeah, if you have a hands-on in cell scripting, Arun, that's always a good advantage. Because cell scripting also we mostly consider under the DevOps. The DevOps is a big umbrella. Okay. Company, they also need some scripting tool. For example, Syngene is looking for cell scripting guy also. They should have some knowledge and good knowledge in cell scripting. Okay. Some guys might ask Python. Somebody might does not ask anything. They might ask only Ansible. Okay. So depend upon company to company and the project to project. So if you have a good understanding cell scripting, so it's good. You know, it will help you in especially in Syngene. Okay. In Accenture, according to the requirement, they are not asking cell scripting right now, but because you have a knowledge, that experience will help you to understanding some of the concept what we're going to learn today and tomorrow. Okay.
Mastering Git Linux.
So when will Linux will have online training courses? We include both in detail. Paresh, we already have it. So we have #13 portal. So we have 100 plus courses and all the advanced courses like DevOps, Kubernetes, quantum computing, metaverse, full stack, and Argo CD. We have individual tool like cryptography. Almost all the core tools, training, Splunk, Prometheus, only Grafana, only Terraform, only Kubernetes, only OpenShift, only service message tube. So we have all the courses available in our #me portal as a recorded courses. Guys, don't worry. Does not matter whichever domain you are in, whichever field you are in, I don't know how much experience you are in. We are trying to help almost everyone. Okay. Only thing, you should be good in DevOps. That's the key. Okay. Right now, this is the only requirement. And two things we are helping you in switching the job and getting the hike, depend upon whatever suit at your current portfolio. So I have 10 experience in AWS. So Surendu, if you have a 10-year experience on AWS cloud and working in Sonata, right now we have not hosted yet, but right now we have some opening in Amazon who are good in Amazon cloud defense services and the architecture. That job opening is for the experience guys. We have not yet post this. My team is about to post my day or two. So it's again from the referral, okay, in Amazon directly. So if you're looking to switch to Amazon cloud or sorry, Amazon company, AWS team, okay, and only criteria what they're looking for, experience guys, 10 years experience is nice. Okay. And second criteria is they're good package, that's good for you. And third, only thing is they are looking for good experience in the AWS services. Okay, especially in optimizing the services, especially the cost analysis part and all the stuff, right? So if you're good in it, so when you can ping your resume to me in my LinkedIn or to my team, okay, and we will send your resume to my connections. Okay, so they are urgently looking for, right? I think yesterday only, I believe we got this requirement. My team is about to share to everyone in your respective groups, but you can send your resume to So Vishal, what we do, we now this year, because we have a target to have 5,000 placements for freshers and the experience. 2 batch we did for the fresher already. 1 batch right now we're doing for experienced guys. And approach would be as a new company come up, we see what they're looking for. So the delta part, some of the part we discussed today, remain delta part, we will again call you guys on that for the XYZ company and we'll quickly train you. Okay, so that's what the kind of recursion we keep on doing continuously for a couple of months. Okay, this is one thing we're doing. And one more thing we're doing, that's what we done for freshers also. Someone say they are very new in in DevOps, okay, and they want to go for a complete process from end to end. Means they want to learn first every tool in detail, then they want to go for the job. Okay, because only by just learning quick tips for the XYZ company might give you a job, but you won't able to perform in the company because you don't have no experience of DevOps. This could be one challenge after you getting the job. So anyone who are into this particular slab, that you guys are very new in DevOps, you have no idea in DevOps, then maybe you somehow will get the job, but you won't able to perform. So for them, for the freshers, what we have come with the initiative. So what a company coming in my April and May month. So for the fresher, we are running a 3-month program where we teach every DevOps tool from basic to all the advanced concept, like complete Docker, complete Ansible, complete Terraform, complete Kubernetes, and many other tools, so that they are complete knowledge they have in the DevOps. Then, and plus we depend in such a way uh, in such a way that any company come with us in April and May month. They are eligible for everyone because they know everything about DevOps. Okay, so this is kind of job initiative we are doing for the freshers. Okay, and that's what we're doing. Okay, but there's two things is going on. One, what we are doing right now is job come up with Accenture. With quick boot camp we are doing for 2 days. Quickly revise what they're gonna ask you, so we can very quickly go and go for the process of the interview, whatever they're gonna ask. That's what we're preparing you. So I am working in the Linux admin 10 years now. And what is the automation? What is the scope of Linux admin? Linux admin role will be there, Rakesh. Only thing is your mindset will be changed. Now, whatever you're doing in the Linux admin, you have to make it automated. And there's a fantastic tool we use called Ansible. So highly recommend, if you're Linux admin, okay, start implementing your task, whatever you're doing, your backup or your configuration, your patching, whatever you're doing in Linux, okay, do it with Ansible. So Ansible is a tool who will automate all your Linux tasks. Okay, maybe you are using scripting till date, scripting, but now switching from scripting to the Ansible. Why? Because when you start learning Ansible, you come to know the power of Ansible. Okay, that I highly recommend right now, Rakesh, to you. Okay, but if you go more deep, better roles, better packages, then move toward DevOps, the entire journey, where Terraform, Kubernetes, Docker, and many things gonna come. That I suggest. Okay. So Udemy, we was not in the Udemy as such. I just quickly launched some of the quick courses, but the entire portfolio of Linux World courses. Okay, we do some of the training online. Most of the things we have recorded courses. So we have our own portal like Udemy. That's called #13. So where you find all the courses of Linux World, complete course, basic to advanced, for multiple different domains. Okay, the portal, the back end of portal is there. I think most of the students working learning. My front end is in the progress. So if you go for learning.hash13.com, okay. So we have entire code. One more, guys. I don't want this black skin come up. Okay. So come up. Even though, guys, we also give everyone account to this portal, because I told you some of the topic, most of the topic what they're going to ask you in interview, I'm going to cover here with hands-on in some time. Okay, but remaining topic, what I want you to a quick brush up. So we'll give you one login to you guys, and this portal you can access as an LMS portal. Okay, and those topics we will provide you here. It's free, obviously, so you can very quickly go for remaining topics. But if you see, we have an expert course in DevOps, Docker, web testing, Selenium, cell scripting, and 100+ courses we have over here. Okay, so almost all the possible tools and technology. Different Amazon Q, only prompt only prompt engineering, only NLP, pure AWS cloud, AWS security, AWS DevOps, AWS machine learning, only JavaScript. So you can go and get from here. Okay, so we just change our front end. My front end will be come soon, but it's a complete backend. My complete LMS is working fine, so you can go and pick the courses from here. And for this, you can contact our team. Okay. Can you share the interview questions demo? Yes, money we will do so. So after, guys, this 2 days, based on the assessment, we will shortlist, that I told you already. And after shortlist students or candidates or professionals here, We do some mock interviews that will help you guys from our side, and we also give you some interview question set what could be asked in Sinji and Accenture. Okay, so that's also what we do, guys. I told you today in the morning we will handhold you guys from end to end. So don't worry about this. So we are taking this responsibility to help you in the job switch or hike. Yes, future batch also for experience. We have both for freshers also and experience also. We keep on coming for multiple batches as per multiple factors. One factor could be my schedule also, and and many other things also. But we keep on coming with. So I'm into SAP 4 year. I want to switch to DevOps. Why not? You can.
प्रैक्टिकल कम कराई थी थ्योरी पूरा
MLOps is also a good profile you can go. I suggest before you go for MLOps, start with DevOps, because getting the DAC MLO job, we have a lot of experience and the freshers who get MLOps job, who get DevSecOps jobs. Okay, but little bit is harder. It's based upon your current experience or knowledge. But I always suggest, if you want to go for MLOps, first start with DevOps, because getting the DevOps job is competitive, very easy. And then in the company, just start trying to switch yourself internally toward the machine learning or data science or AI. Okay, in the role called MLOps. That will give you a quick way in getting MLOps, because in the MLOps, finally you have to use DevOps only, right? So it started with the DevOps experience, then slowly move toward MLOps. Okay, so that's all, guys. I think we have hundreds of questions. I try to touch as much as possible. So let's do one thing. Let's go for quick lunch break. Okay, lunch break. And after lunch break, guys, we have assessment. That's very important. That's based on the assessment. My team is going to shortlist you guys. Okay, and those CV will be provided to these companies, and then we'll go, guys, to one by one topic. Okay, and the first topic will be Docker. And we'll invest 2 hours on Docker, then we move to Kubernetes. And this now onwards, it will be complete practicals and hands-on. Okay, so that's it, guys. So let's have a quick break of almost 45 minutes. So in IST time, we will continue resume at 3:15, guys. So 3:15, we will resume our sessions, guys.
लगभग 2:30 बजे तक चला सुबह से, कल रात की जबकि चला परसों में चार्जेस लगाए थे।
हम आपको कल हम फुल ब्राइटनेस में एडिट करके चालू कर रहे हैं और क्लास में खाली है कल रिकॉर्डिंग एडिट चला है और ब्राइटनेस हम फुल कर रहे हैं और 1:30 बजे हम रात के लगाए चार्ज
और मतलब परसों के आज चार्ज अभी तक चला।
ओके जितना
और Argo CD, Istio, Service Mesh, Prometheus, Grafana. Okay, so these tools will explore, go kind of more in detail, will be around the Kubernetes, right? But before the Kubernetes, you should learn something about Docker. Okay, without Docker or container, you won't be able to understand and properly use the Kubernetes. So I would like to invest almost half an hour on the Docker to give you some of the important concepts of the Docker. Okay, and after Docker, we will move to Kubernetes. Okay, so first of all, guys, Docker is a software Okay, and the use of the software or this product or tool would be, okay, if you want to launch any OS within a second, then you can use this tool. This is one of the quick use of this tool. Quick use. Otherwise, they will help you in many more other area also. We'll talk in some minute. So from here, I would like to so the hands-on. Okay, because Docker is a software. Sorry. Docker is a software, and if you want to run this software, you need some OS. Mostly we use Linux OS. Now it is your choice. You can run the Linux directly in your laptop in VirtualBox somewhere, or you can run the Linux in cloud. So in my case, I am going to use AWS cloud with service called EC2 to launch the Linux, and on the top of the Linux, I am going to run the Docker. Okay, and that's called Docker services, also known as Docker engine. And without Docker, you won't able to run the OS within a second. Okay, so let me start. So in my case, I am using AWS cloud. Those who don't have the account, you can go to aws.amazon.com, create a new account. Otherwise, you can use any cloud, does not matter. Okay, or maybe you can use some local Linux machines also. So that is one thing. But in my case, I already have the account and I log into my account, and there's a service called EC2. You can go and search this service, EC2, that will give OS in the cloud. Okay. And now I'm going to launch one Linux OS here. How to launch is very straightforward. So I just click on launch instance. I'm just giving this OS a name. Let's say Docker OS, just a name. And here I'm going to use one OS. You can go for Red Hat Linux or Ubuntu. I'm going to use Amazon Linux. Okay. And the hardware type would be T2 micro. So 1 GB RAM is enough. Okay, enough. But it's a free tier. So if you're a new account, it won't charge you. But in my case, I'm just using something more bigger. In your case, you can go for T2 micro. That will work. But I'm going to use T2 medium for my demos. And that's it. Nothing new. Nothing else we want, right? So there's a minimum requirement we will use, and key pair I am going to use without key pair to log into this machine. Okay, and that's all. Click and launch. So straightforward, nothing very technical. So finally, I am launching one Linux OS because my plan is to run Docker services. That's called Docker engine. That's my plan. So for this, I need the OS. This OS has been launched somewhere. In my case, it is running in the cloud. Now to log into this OS, very straightforward. AWS Cloud given you a quick way to log into this OS. Okay, so I'll click on this OS. Now it is running. There's a button called Connect. Click on the Connect, and there's a one button called Connect. So it will log in to this OS. I will have to repeat. 1 minute. I just need Linux OS. It is not compulsory that you have to use AWS Cloud. I recommend you can use AWS Cloud if you can. Otherwise, you can use any other way. I just need. Okay. Now I log into my root account with sudo command because I want to install some software. So I need a root power. So I'm logging in as a root account. Okay. And for installing the Docker, I can use yum command. Yum is a command we use in Linux on Amazon Linux, and the software name is called Docker. I am using yum command to install this software. And Docker is actually a services. To after installing the software, I have to install I have to start a service called Docker services. That's all, guys. So it's very, very straightforward. One or two command, your Docker engine has been started. So after the software installed, you can run the command called systemctl start Docker. That's it. Now this Linux machine running with the Docker and any machine running with the Docker are also known as Docker host. So this machine is working as the one who is hosting the Docker is called Docker host. Okay, and to confirm it's a Docker host, you can run the Docker info command. If this command is working, there's no error. It's working. If there's no error, so this machine, Amazon Linux, is working for me as a Docker host. And Docker server is running. Okay, with this version. Now, why we need Docker? Because with the help of Docker, I can. And why you want to launch the OS within a second? Because I want things to be very, very fast. Because I have a lot of requirement. Okay, in my CI/CD pipeline, the way I explained to you, one of the requirement could be testing. So whenever I want to test, I'm going to test hundreds and thousands of time day. Okay, and for every time for testing, I need the OS. So in this OS, I can run some app or some testing tool who help me to test. After test complete, I want to terminate this OS and launch again one more time. Okay, so testing might take 1 minute, 2 minutes, 1 hour, I don't know. So that I can control much, but launching the OS, I can control the time. I can launch this OS in less than a second. Okay, so at least we can save some time. And more time you save, in running a CI/CD pipeline, and means you have a faster time to market. And that means you will have a bigger business because you reach to market quickly. That's a core idea, right? And if you just very quickly, if I talk of Google, so if you read the case to Google, in a Google, they launch a container, almost 1 billion container they launch per week. That is a kind of scale they have. In a week, they launch a new container and they terminate the containers by doing something, whatever they're doing. Okay, almost 1 billion container. Okay, they are running or launching and removing per week. So you can think, guys, that's much time we want. So if they're not running the container, then it is not possible. Whatever they're doing in those 1 billion time, it won't be possible so much scale and so much faster. Okay, but because of a container, they can launch a container, delete a container, stop the container very, very quickly. So that will save a lot of time. So whatever they're trying to do, very quick. Okay. So that's one point. So, but for launching the OS with the help of Docker, what we need, the minimum requirement is, if you want to use Docker or any tool for launching the OS, okay, we need OS bootable file that's called image. Without image, it is not possible to launch any OS. And in the world of Docker, those images called Docker image or container image. And right now, at this point in time, I don't have any images. So there's a command called Docker images. I don't have an image. And without image, you won't able to launch a OS. There's a command called OS is running. And one more small thing, guys, in the world of Docker, the OS is technically known as container. So when I say OS or the container, it is the same thing. Same thing. Now, for launching the OS, you need an image. And this image is mostly provided by a respective company. Red Hat, they have their own image, Ubuntu, Fedora, CentOS, Windows. Okay. To launch. So there's a site called hub.docker.com. Is a kind of public location that's called registry. Okay. Where any OS images, whatever looking for, you can find here. For example, I'm looking for Ubuntu OS. Okay, Ubuntu, some billion download they have over here. Or you're looking for Red Hat, for example. So if you search for Red Hat, so you can find Red Hat images. Red Hat 8, Red Hat 9, and so on. Okay, so whichever OS you would like to use, you need an image. And this image is mostly provided by their XYZ company, okay, are known as distributions or distro. So Red Hat have the Red Hat distro image, Ubuntu has the distro images. Okay, so this image, how to download? And for downloading, wherever Docker engine is running in your Linux system, you can under command docker pull, then give the image name Ubuntu. Okay, whatever the name would be. In my case, let's say I want to download Red Hat version, let's say 9, or let me use 8. So the image name is called Red Hat /UBI. What are the name they have given? That's okay. 8. And sometimes, guys, they also give you some subversion also. So if you click on this name, they also sometimes tell you here the command to download. Plus, this is the command I'm going to use. Plus, they also give you tags. That's called versions. So Red Hat 8 has subversions, latest version, or this 8.10 version, 8.11 version. So whichever version you want to download, you can download. Okay. Let's say I want to download version 8.10. That's called version order tag. I can write 8.10. So the syntax would be you have to give the image name, colon, then the tag name. So this image in your local registry in the Docker host. So only once we have to download, after image is gonna come up. Okay, that's all. So from the image, we can launch the container very quickly. How? So there's a command called docker run. I want to run means launch a container from this image UBI 8 colon the tag and the version is 8.10. There's no space between. And what I want my content to be launched. And after the launch, I need a terminal of this OS, and terminal would be interactive. And this OS, I would like to give a name. Let's say OS1 is just a name. You can give any OS, this container, that's all. Okay. And you can see, guys, it's just in one click. See here? That's all, right? Fantastic. So this was using Linux. I was using base system called Amazon Linux, but right now what I'm having Red Hat version 8. They have their own personal commands. They have their own personal file system. They have own personal kind of memory, RAM. Free command is not working by chance, but we can install the software. Okay, and that's one more thing. This is an independent OS that is called container launched from this image. But one more thing I want to add, whatever this image content that will given into this OS. You can think this image like a C drive in Windows. So whatever they have in the C drive, when you start the Windows, you can get the same content. So whatever come from the image will come to the container. And if I shut down the container, there's an exit command. You can OS shut down, and you're going to see how many container is running right now. Nothing, because I shut down with exit command. So it's exited 8 seconds ago. In a second, from the same image. Okay, whatever. But if you want to come out from this container without setting PQ as a shortcut, Control PQ, then this OS does not shut down, and you come out from this container to your base system. And now you can run docker ps command. You can see this OS is still running. Then those who are very more deep into this topic. running. And if you want to shut down this container without going, then it will work. And you can see A option to see everything is running or shut down. It's meant as container. And all the You want to run database. In this container, you want to run front end, back end. We are explaining over Facebook microservice. And this entire search app I can run in this container. The chat app. Good thing is you don't have to. And Docker has given the network facility. So Docker is the one who gives the IP address. They are the one who give the network connectivity. So you don't have to worry about any network setting that is given by the Docker. Okay, that's one thing. Okay, but understand one thing. Primary use of the Docker is they give you a image. Okay, and this is the image from the distro. You guys are saying my voice is not coming properly. Let me reconnect. I believe, yes, I believe. So, what I'm talking about. So Docker, say we are giving the image, and from the image you can launch the container. Okay, that is within a second. That is my primary goal. Done, and you have your container running. That's all. But understand one thing. This container I launched from my Red Hat distro image, and Red Hat has given me limited thing. They give me date command. They might does not give me ifconfig command. They might give me IP address command. I don't know. But they're not giving. But this OS is not usable. Okay, they launched the OS. One of the primary challenge of launching the OS within a second is save. So my overall pipeline can be run very quickly. Okay, but this OS is not usable because we don't use OS directly, right? We use OS by running some app. So you want to run the database, you want to run some testing tool, you want to run some SonarQube tool or Selenium tool or security scanning tool or your backend and front end. Okay, that's what we use, right? So they launch a container, is a raw container they launch from base OS, let's say Red Hat 8 or 9, whatever version I use here. But this OS launch within a second, that's nice. That's what we're looking for, but it is not finally usable. Okay, because in the OS, we use the OS for run the app. Okay, but if you want to run the app, okay, only base OS is not enough because there's a possibility your developer has developed the app in some language. Let's say if they create in a language called Python. So your base OS also need Python runtime or Java runtime. But I don't have it. I don't have Python here, Python 3 for example. So what you can do, okay, there's two possibility. One possibility is you can find some images in the Docker Hub where you can have pre-installed Python. So you search for Python, you can find some images where someone has contributed the account and contribute here, and somebody from the community also of Python. So what they have done, they create an image where they use some base Linux OS and they give you pre-installed Python. If you use this image. Okay, this is one of the way. Or other way would be I can use some raw OS, install the Python from my side. How? By their command, let's say yum install Python. Which one is better? Depend. Because maybe the community guys has given some Python version, maybe 3.10.1, but I'm looking for 3.10.2 based on my requirement. So whatever they give you might not be suitable for my application. So mostly we have to set up our own configuration. And because this is a Red Hat Linux. So I have to install with Python yum command, and they give me this is software available. Let's say I'm looking for Python 3.9. So this software name I can use. Okay. So what I'm doing, I am having a container that work like a real OS, and then based on my requirement, I install Python some version, so that any app that is developed by my developer can run because of the Python runtime. And now I can see Python was not there, but now it is come up, Python 3.9. Let me exit from here. But again, Python is not alone enough, because mostly when my developer write a app, they mostly write a lesser web app. And web app, guys, mostly we use a web app framework. One of the famous framework in the Python, Django or the Flask. Or if you go to Java, we have a Spring Boot. Okay, so if the developer write a code in the Flask, then your base OS need Flask library. Otherwise, your code will not work. Okay, so here we have to install some Flask library. How? There's a pip command in Linux or Windows to install Python library, and the library, let's say I'm looking for Flask. So what I'm trying to tell you, okay, Docker has given you base OS within a second. That is the power of Docker. But the base OS is like a raw OS. It is not enough for our app. Okay, for the app, we have to first configure our OS based upon the requirements. It's called setting up the environment. And for this, for configuring, we have to run some command. Now, it is your choice. These command, what I'm running for configure my OS, because my app that is going to run in some time, they need Flask or Python, many more settings known as configuration. Now, it is your choice. These configuration, this config management, either you can do manually, the way I'm doing right now, or you can do this configuration automatically. Okay, how? Again, there's two way to do automation. Okay, automation means my OS will do for me, my program will do for me, rather than I type by myself. Automation or imperative way. So in the automation world, there's two different kind of approach we can use: imperative or declarative. Imperative means, okay, old approach means you tell to some of the automation tool or program, okay, what to do and how to do. Means I want to install Python. This is what, but how? Yum command. The yum command or pip command thing won't work. And this is what we use in the shell scripting. So if you know shell scripting or PowerShell, we use for automation, but the approach will be imperative. So the shell scripting, if it does not know yum command, skip won't work, right? But if you want to go declarative approach, it is more like an intelligent approach. Okay, where you only tell what to do. How to do, you don't need to tell. This tool is kind of very intelligent. You tell your requirement, and they know the OS underlying tools or the commands. So example, I just tell to my declarative tool that I want to store Python. Okay, those two will automatically figure out. And if underlying OS is Ubuntu, they call apt or apt get command. One of the example of this tool is Ansible. But the point, if you want a configuration management to be automatically, you can use either of this approach, whichever you want to use. But right now I'm doing it manual way. Manual way. It's dropping. Someone guys says, let me 1 minute. So yeah. So I'm doing it in the manual way right now for some reason. Okay, for some reason, the reason I'll tell you in a minute. Okay, so right now what I'm doing, I am configuring this OS called container for installing Python as a runtime, Flask as a library. Now what I can do, I can tell my developer, whatever code you write, give me the code, I can run it. And what normally do, this is not part of your duty. Developers or web app developers or full stack developers, they write a code, and after writing the code, they upload in GitHub. Okay, and then you will download this code where in this OS, and this OS is nothing, your container. Okay, in this OS, so that you can run. So right now, let me say I am a developer. I'm writing this code. Obviously, guys, this is not your and our duty as a DevOps engineer. We don't have to write the app that has been given by. Sorry, my voice is audible, clear. I don't know what is the challenge. 1 minute, guys. Mike, again, if you can confirm my voice is clear now. Yeah, thank you very much. So, yeah. So one of your developer write a code and upload in GitHub, and then you download the code somewhere here. Okay, run the code. Okay, so that's what we can do. So right now, let me do this part very quickly. You don't need to develop the code, but right now what I'm doing, let's say I'm a developer. To give this concept, I'm a developer, so I'm going to GitHub, and in the GitHub I'm going to create a new. If you don't have an account of GitHub, you go and create it somewhere we use, especially when we go for Kubernetes and Argo CD. Without GitHub, we won't able to do there. Okay, so I'll have a GitHub account. Otherwise, you can go and create the account. So let me create one repository in the GitHub, like a folder, and let's say this is a 2 days free job preparation experience, guys, 2025. Okay, so this is a repository name, and that's all. Don't click on this button. Okay, and let me create the repository. So it's like a central repository in the GitHub. And what I want to do, I want to write a code in my local laptop, and I'm going to upload here. And for this, you need one tool in your local system. So you can go for Git Bash is one of the way. So this tool you can download from Mac or Windows. In my case, this tool I only downloaded for Windows. What this tool will give you. So after you install this tool will give you a command prompt, more look like a Linux command prompt in your Windows called shell. But this tool also give you git command. This command will help me to upload and download the code from GitHub. Okay, so that's what I'm going to use. And because I'm going to write a lot of code here, so in my Windows, I'll go to somewhere my download folder or document folder. And then what I am going to do here, let me create one more folder here. Let's say free job preparation, one folder for experience 2025, just a folder name. Let me go to this folder. This will be my workspace, is empty. And now very basic thing, I think this part you might know, git things, and they give you these command here to create a local repository. So let me copy this command and paste over here. So what it'll do, nothing. Your local Windows has been connected to GitHub. Now, whatever you do in local laptop, that's more like a workspace for the developer. It will be uploaded to the GitHub. And after you run this command, if you refresh this page, you will see some new thing gonna come up. So it is nothing. There's a one file called README that is there in my local laptop. It is been uploaded. My point is now you don't need to go to GitHub. Okay. So let's say according to my diagram, I am a developer. I'm sitting in my local Windows in this terminal, and whatever I type here, it will be uploaded to GitHub. And why I want to upload to GitHub? It will be a central tool. My other team can download this code wherever they want to use. Okay. So what I'm going to do, let's say I'm a developer. I'm going to write a code. Your code name could be anything. Let me use app.py. This code you don't need to understand. This is done by the developer. So right now you are the DevOps engineer, SRE engineer. So you can skip this part, what and this tool code will do. But let me write this code very, very quickly. So from Flask, I'm going to import Flask function, and this function is going to run in my main function. Is my app. I'm going to create a function called Linux World, and this function is going to return welcome to Linux World dot. Now this app I want to run. Right, they're going to run with the port number 5000. So app is being created. Let's go path. And if anyone come to /info path in my URL, so where the app run, they have the URL. If someone come to /info, this function run automatically and they return welcome to the next one. So this will be output when someone hit this page. So that's all, guys. The developer will create this app for you. Okay, but right now they're creating on local machine. So let me upload by git add. I'm adding all this file, git commit. Before upload, we have to commit with some message. Let's say first code. This is message. And let me do git push. Now from local machines, my developer is uploading this code to GitHub. Now you can see in the GitHub, this is coming here. Fantastic. Now developer duty is done. Okay. And let's say I want to run this code in my container. So wherever you have the container, go there. Now there's two approach. The first approach is I can download the code directly in the container. This is one of the approach we can use. Okay. But sometimes guys, we run for some time, then we'll delete. So downloading the code directly in the container, sometime you can do, but it's not good approach. So what we can do, let me come out from this container with control PQ. Okay. So my container is still running in the background with this container name. And this is my base system. Base system. So let me do one thing in my base system. I'm going to get one folder, let's say /code folder. Nothing, you can give any name. Any name. Here I'm going to put all of my code. So the base system, and in the base system, where this is called Docker engine or Docker host, I'll go to my GitHub, take this URL, and do git clone command to download the code to a base system. Git command is not there in my base system, no issues. I can install the git command into my base system only once. So this is my Docker host. I am downloading the code into my Docker host. You can see the code has been downloaded from my GitHub. So this code is being managed by my developer team, and I downloaded here. Right now, after code is there in the Docker host, from the Docker host, I can copy this code to any of my container. So Docker copy command. And I say there's a file called app.py. Okay, there's a file we have file we have, and this file I want to copy into one of my content. Due to many content also. So in this container, I want to copy where in some of the folder, let's say slash folder. That's all. Okay. So you can directly download also in your base container, but I'll tell you the reason in one more time, the different way think of why to download the code in the base system. I'll tell you. Okay. But after having the code in the base system, means where the Docker host is running. Okay. Now from there, your code, your file, your data could be copied. Just give content ID or the name and colon and the folder. Now, if you go inside the container, how? Any content is running behind the scene. If you want to go inside the container, there's a command called docker execute command. Okay, so any content that is running, if you want to go inside, then execute command we use, and then you have to give the container name, and then give IT as option. Have an enter to terminal. And you guys, one more thing. If any OS, if you want to access the OS, you need a shell. Mostly use the shell called bash. So any content that's running in the background, that will come out with control PQ as a shortcut. If you again want to go in, this is one of the way you can use execute IT OS name means container name and the bash prompt. Again, read the same container. Okay, it was same contents here. What we are doing till now. But here, what you see, because we copied already in the slash location, so it's my slash folder, you can find this app has been copied. Into my this diagram, if you want an app to be run, so first requirement is you need base OS that is launched by Docker very quickly. Then we need runtime or the library and other configuration that we have done manually. And then we have an app, somehow we copied or downloaded. After having these three things, okay, now this OS is usable. Because now in this OS, we can run my app. How? Simple, just Python command, because it's Python app. My app. If a code is written right, there's no syntax error. My app run successfully. Fantastic here. App is running successfully. And this app is a Flask app, and they give me this URL. And even hit this URL, they can see my site. Okay, so how to access this URL? So one of the ways, let me do Control C to stop. Okay, and you guys know one of the shortcut in Linux, if you think any app is keep on running, but if you want to run this app in the background, so in the Linux, there's a shortcut called this symbol that will run your program behind the scene. You can see jobs is a command to see your program is running behind the scene. Okay, and why I'm doing so? So that I can connect to this URL. And one of the way to connect to the URL is curl command, is a client side tool. I can say HTTP : this is the IP address of my current OS, and the app is running on port number 5000. And the way I have created the app, in my app, I have written that if app is connected with this endpoint. So anyone who connects this app, they have to write this endpoint, that's called route, or sometimes also known as API. Here, you can see output welcome to Linux. This is what I asked them to print. So thing is working fine. But right now, everything guys is running inside the container. Inside the container. Okay. Now, Docker say, okay, if you launch a container, I can launch within a second, but this container is not useful, guys, because it's a raw OS. It's a raw OS. Okay, what you have to do to make it usable, we have to first install a lot of configurations, install software, libraries, runtime, depend upon app to app. Then we have to copy the app code. And then finally, execute the app. After doing all the four things, then this OS is usable, then your client can able to connect by somehow. Okay, otherwise it is not usable. Launching the OS is very quick, but remaining portion, this is manual, this is manual, this is manual, or maybe you can use Ansible or shell scripting to make it automate. But even though if you use shell scripting or the or the, I can say, the Ansible, they can set up this part automatically, but again setting will take a lot of time. They will install the software, they will configure something, take time, right? If you think this part we need always, we need this runtime, this library, this code always. So what we can do, we can create our own custom image that contain all these things. Okay, so this is use of the custom image. Okay, creating this image take some time, but after this image come up, okay, this become the Docker image, and the power of the Docker image is after image created, okay, the launching the container from this image is less than 1 second. But now this time, this container, what I launched from this custom image contain everything. They contain raw OS, they contain runtime, code, and plus they also run the code. So from this custom image, when you want to launch the app, hundreds of times, 1,000 times for testing, you don't have to reinstall again, reconfigure again. Everything is provided in the image. This is called custom image. And to create a custom image, there's a multiple way, but one of the better way to create the custom image is using Dockerfile. Dockerfile is some kind of code given by the Docker by using some keyword. Okay, and after running this file, you can create the custom image. Okay, so let me exit from here. Let me do one thing. Let me stop my container. I just want to show this demo, but now let me stop this container. I don't want to use this. The container is stopped. I'm going to create a file called Dockerfile, where D is capital. There's no space. And here, okay, whatever you do, let me write this code first in my window, then I copy paste. Okay, whatever you do manually, okay, so if you guys remember manually, the first thing what I did is I use this base image. Okay, so whatever you do manually right here, so first I use this base image. The inside this image I install Python 3.9, then I install Flask library. Then I copy my app.py from a local computer to one of my folder. Well, let's say this folder I want to create. Let's say one folder called my code folder, and let me go to this folder, and then I copy to this folder my app. My app. Okay, and then finally I run Python 3. I run this code. This is almost what I did manually. Okay, but if you think this part you always need, put everything in the image. But to put in the image, you should know what you need. So first, I'm just trying to give you the approach. First, write down all the stuff what you need, what you do manually, and then give this information to Docker file. And in Docker file, guys, we have a keyword for this. If you want to use this base image, then we have keyword called from. So if you go to Docker document and Docker file, keywords, for everything, this is the keyword you can find. So from is a keyword, means which base image you want to use. Okay, and Then from will launch this container automatically, and in this container, whichever command you want to run, then is a run command. This is called run keyword. You can find run command. So there's one of the command I want to run. This is one of the command I want to run. And then I want to create this folder and I want to go to this folder. So this is also a command, but this is a very common thing. You create a folder and then go inside the folder. And this folder is mostly the workspace for the developers or for the app. So instead we write these two commands, we have specific keyword for this called work dir app. The work dir is keyword you can find. It will do two things. First, they will create this folder and then they will go inside this folder and make this folder as a root folder for you. Okay. Now, whatever you will run, you don't have to type the entire path. You will just type slash. So this slash is nothing, is this root folder. Now this becomes root folder. Now, if you want to copy something, you didn't have to type entire path, you just tell slash, and this slash is nothing, this slash. Or maybe you don't use slash, this by default they use this is a path. Okay. Or anything that you want to copy from base system, then we copy command. So what copy command will do, wherever Docker file is running, okay, same location, they will take this file from the base system and they copy inside the new image to this folder. And that is one of the reasons why I downloaded my local file, local computer. Because Docker file will go to local computer, take this code from the same location, or otherwise you can give the path also. Or to tell you are in the same location, you can add / means current location. So in the current location where I'm going to create this file, they take this code and copy in the new image to this location. And then I run this command. But understand one thing. Creating the custom image. For creating the custom image, we use Docker file. Docker file is a way of writing the code, and the code look like this. Okay, and this file we will run. It will create the custom image. This is called build process. Build process. After image create, now from the image we can launch the container. This called runtime or run process. It's called build time. So what I want, okay, I want my app will run when the container launch, because there's no good reason. You won't say that I want to run VLC player or Firefox in my hard disk. We never run in the hard disk, right? In C drive. We install the Firefox in C drive. We install the Firefox or any software in hard disk. But any program when you run, it will run on the runtime of the OS. After first boot the OS, then we run the program. Similarly, here, we install the software in the hard disk. In my case, the hard disk image. Image when you launch the OS, then only we want to run the program. Program will always run when my OS is running. Okay, that is the reason. If you think store inside the custom image, this called build time, and for build time we have to use run keyword. But from the image, when you launch the container, that time if you want any program to be run automatically, okay, this is what I want, my program will run automatically. But this program will run only if when my container launch from the image. It's called runtime. And for the runtime, we have a keyword called entry point. There's one more keyword for this that most guys does not use in the right way. This called CMD that I don't recommend here. Instead, we recommend entry point. Why? I'll tell you. So to run any command in Docker file, you can use run keyword or the entry point keyword or the CMD keyword. But the only difference is run command will run at the build time, and whatever run at the build time of the image, they will store in the image like a hard disk. But whatever you write the command with entry point or the CMD, they are same thing, but they have some different. Okay, so these commands run only when from the image you launch the container. Okay, that's the big difference. So this is a runtime command, and this is the build time command. And entry point, guys, has some syntax. You can click on the entry point, you can see the syntax. You write your code in double quote as a list, then comma, this argument. That's all. And this is the Docker file. Okay, so right now I'm not doing a manual, I'm not doing Ansible or self-scripting my configuration. I'm putting everything is pre-bagged. So it's called pre-bagged. So pre-prepare images. Okay, because if you're looking for the performance, if sudden requirement come up, sudden load come up in your server, you don't go and configure something on the real time, right? You want everything to pre-bagged, pre-bagged. Okay, so that when the requirement come up, if I need one more OS to be launched to balance the load, it's called load balancing. I'll show you this demo in the Kubernetes, the same image. So thing will work very, very quickly. Okay, because we have everything pre-prepared and we have to just launch it. And launching Docker is super fast. One click, they launch everything. So this is a guy's image code I created, and I want to run this code in my Linux system, because this code can run only where the Docker engine is running. So here I go and create one file. The name is called Docker file. You can change the name, but this was mostly the name we use. Let me paste this code here. Save. This is what the code is, and same location we have this app also that I downloaded with my GitHub. Okay, so technically, what we have finally, we have a code. We have a code by the developer that I downloaded. This is not our duty to create this code, but our duty is to get this file. But right now, guys, I'm using pure Docker. So this file you have to create. But if you use OpenShift, in OpenShift, guys, what we can do, we can tell this URL. OpenShift will download this code, analyze this code automatically, and behind the scene, they understand this is Python, this is Flask, and this Docker file they will create automatically for you. So this is one of the extra benefit OpenShift will give to you. And this concept in OpenShift is one tool from Red Hat. It's called build configuration. It's called BC. So the concept of build configuration in the world of OpenShift, okay, where they automatically do this part for you. This concept is not there in Kubernetes also. OpenShift has given this extra concept behind this. Okay, so there's one point. But here we're learning, so I'm just doing it manually. Okay, so Docker file we have created. And let me run this file and how to run. Okay, then we command called docker build. Then I can tell T to image, and I can give the version of the image, and then I can dot means current location. So this command will go to current folder. They look for this file. This is a by default file, and the build a new image with this name and this version. That's all. Now everything is complete automatic. To create this image, this code, then everything automated. But understand one thing: whatever command you use, this command should be non-interactive. For example, yum command will always ask yes or no. And because Docker does not know how to pass yes or no, so they fail here. If you see, they fail here. So if you're using any command, those commands would be non-interactive. So if you ask yum, how can I make you non-interactive? So no, without asking yes or no, it will work. This one. Remove and open this file and paste the code. In entry point or the run keyword, it should be non-interactive. How can we make you non-interactive? And finally, you will have your custom image. And the build time, if you want to run any command, then you have to use run keyword. Okay, run keyword. So build is going on, and finally the image has created. And now if you run the Docker images command, you can see one image we created right now. This name and this was. Okay. You see the history of image, you can see history also. History will tell you how this image is created. In this image, we have used copy this, working directory, we use this command, that command. But in this image, the one keyword is called entry point. And if you notice, guys, here while building entry point, everything run. My yum command run, everything run. Pip command run. But my this command does not run. Why? Because entry point is not the build time keyword. This command only run from if you launch container from the image. So whenever you launch container from the image, this command automatically run. And what is this command? This command is going to launch the app. Okay. So now this image created. Now how to launch the container? The run command. IT, that's all. And now what you will see, as soon as you launch the container, is launch within a second. Not many things. Code, everything is there. Everything will launch within a second. Plus, they also run my program or my app automatically. So when you get, when I hit enter, you can see Flask always start. Fantastic, right? But any app that is keep on running, I don't want they will run on the foreground because they does not allow me to the remaining part in the same terminal. So let me do Control C. You want to launch any app, and app is one thing that's keep on running. So in the Docker world, you can use D option. D means daemonize or detach mode. So in this case, this container will run in the background and container running the app. So app is running in the background. And if you want to give the container name, if you want, you can give. Let's say name of the container is called OS5. It's a 2 hyphen. Now you can see your container is running in the background with this name. Is I launch from this image. But as soon as I launch the image, they automatically run this command. Because I put in. Okay. It means they can run this command, and this command is the one who run the app. I can connect to my app. How? So if you want to know the IP of container, the IP is given by Docker. So there's inspect command we have in the Docker. Tell me the IP of this container because you are the one who give the IP addresses. So IP is 2 in my case. Okay, and because plus any of my system who have a connectivity, I can use the curl command and say this is the URL I have where my IP of my container is 2 running 5000 and I know my endpoint is info. So from my other system, I can able to connect my container and inside the container. Service or this service or this API, whatever say, I can able to connect. But right now, I'm into my base system and you can able to connect one of the app running inside the container. And according to my microservice example, this container could be uh, one microservice like serves. We can have one more microservice called chat, one more microservice post, and Docker given will give everyone a different IP address. So everyone can connect to their IP addresses. Okay, so this is how it works. The point is, okay, the power of the Docker is they can launch the container very quickly from the images, from the images. Okay, there's one beautiful thing. Okay, but what you want in this container is come from image, and we always want to do one thing: put everything in the image. How? With the help of Docker file. You looking for, looking for. You need Java software. You need Maven. You need Maven package, Maven compile, Maven clean. You want Java jar file to run. You want a Spring run, Spring Boot run, whatever you want. Databases, your normal world in your app or databases, you can put in the Docker file with the right keywords, and that's all. As after image created, okay. But the good thing, image known as OCI images, Open Container Initiative, is called standard images. Standard means if you create the image here, the Docker file, okay, here. Now this image you can run in any. You can run with Podman. It's a kind of competitive Docker. You can run with Cryo. You can run this image. Okay, if you guys know some AWS, there's a container services. So if you go to AWS Cloud, okay, where's my AWS account? Here it is. So there's a service called ECS, Elastic Container Service. Cloud services. Okay. No challenge here. My voice. You can deploy here, or you can also run this image in Kubernetes. So any container platform or cloud services, okay, maybe Kubernetes, maybe OpenShift, maybe Mirantis Kubernetes, okay, you can use this image and run as is. Okay, so that is the reason. Okay, mostly we don't run the images directly in the Docker world. Okay, we use Docker or Docker tool for creating the image, so building the image with Docker file. After the image create, we don't run the image. Maybe for testing purpose, you can run the image the way I done, but we don't run directly with the Docker. Instead, this image as a reason is one of the reason is by chance container is running. Container. I don't know, guys. What is challenge here? It's 1 minute. Hello. I think now is come up. I don't know. I think from the Zoom side, maybe possibility they are dropping. Maybe I don't know. So what I'm talking about, my Docker is running container. Docker is managing the networking part. So I can run my app and I can tell my client the URL and they can hit and see the output. So working fine, no challenges. But challenge is if due to some reason, if my app goes down, my container goes down, so I'm manually stopping the container, or they fail because of some bug or some other challenges. Then it could be memory issues, many issues, guys, that will app on the OS. You can see your container stop, stop, then your OS stop, or the application stop. Then if your client trying to connect, it won't work. Disconnect. Okay. It means if any fault come up, okay, if any fault come up, and because this container goes down, there's no one in the Docker to monitor this. So we have to ask some of my operations team. They keep on checking Docker PS command, or they're using some kind of monitoring tool on the top of this. And if they found if one of the container goes down, they have to go somehow manually start this container. Okay. And starting can be done very quickly. As soon as I start, then my application is up, my client can able to connect, it is working. The point is this is a downtime, right? It's down. So when my application goes down, I have a fault every second. Even though you monitor, you might miss some of the seconds. And you have those much second of downtime. One of the microservices goes down, that has a cascading effect that I was talking about, that will bring down on the app. Or there's also possibility guys, I don't know. Can I use my laptop mic? Thus, can you confirm my voice is better if I use my laptop mic? Maybe my checkboard might have an issue. So I'm audible, guys. So what I'm talking about, because Docker does not give a capability, if container goes down or if fault happen, there is no way to tolerate the fault. Okay, no way to tolerate the fault, or maybe something goes down. We have no system here that's called resilience setup. If something goes down, it goes down. That's all. Okay, so that is a reason we need to use Docker. That's what we want. But my management of the container, the monitoring of the container, the resiliency of my setup, I have to control by my COAs tool. So we talk about the container COAs tools. Okay, so one of the famous tool for the COE of the container would be Kubernetes. So here the role of Kubernetes come in play. Kubernetes come in play. Okay, Kubernetes give you capability, and what capability Kubernetes give you? Now onward, you don't need to launch the container by yourself. Only thing that you take the help from Docker is Docker file to create the image. The launching the container would be done by Kubernetes. And the Kubernetes, if something fail, then Kubernetes will handle this part. If one of the container fail, the Kubernetes will relaunch the container automatically. Okay, so you will see always the uptime. Plus, in the Kubernetes, we can add multiple rules also. Maybe my container is running, but sometimes the app will take some time to load. Right? Python is fast; they run very quickly. Java app, so I can launch the container. Okay, but if I run my Java app, Java app will boot. They use JVM or Java runtime. They say it takes some second to start. And by the meantime, they're not starting. I can't send my traffic of my client to this app. So we can write some rule in the Kubernetes and say, we are going, my last container shut down, and but I'm going to launch one more container automatically that is done by Kubernetes. Okay, but this is a Java app. Second, to start the entire app. So I can tell my Kubernetes for 5-10 seconds till the time this app is not running or become healthy. Don't send the traffic. Okay, so here we can use some concept of fault injection, chaos engineering, or these kind of topic. Means if the app is not run, so Kubernetes will send those traffic of the customer to some other app. There's maintenance going on, or maybe sometimes you write multiple app copy as replica. So they're not sending the traffic to this app till the time this app become healthy. So that is also many more things, guys, we can do with the help of Kubernetes. So I'm not saying Kubernetes is launching the container. Kubernetes behind the scenes use Docker or Cryo and other tool like Docker for launching the container. But Kubernetes is just a management tool. Work on the top of Docker. Work on the top of Docker. Okay, and so that these kind of management we can solve. Okay, otherwise Docker is a very big tool itself. I don't want to go more deep into the Docker. There's a lot many things we can do in the world of Docker. So we have exclusive training only in Docker. If you want to learn some in the future, you can join. If you those things, being file. But right now, what you see, how I create this file? My app code from GitHub. I use is I first download the code from GitHub. This was manual. We run the Docker file. Let's go build, and this will create the image. Image used by some other tool or by some other team. So what we have to do, we have to upload this image in some central tool. Other team can use it or the tool can use it. And those central tool is called registry. That is your choice. You can use some cloud registry like a ECR service in AWS cloud, or you can use Docker Hub. Well, 13. So 1 minute, guys. You create an account, and in this account there's a tab called repository where you can upload your images. In the system to Docker Hub with Docker login command. I log in a password Docker Hub. In my case, my account is email13. Your account name could be anything. Then you give your password. You log in. Create it. You can upload, but there's a rule. If you want to upload any image to Docker Hub, your image name start with your account name. Is the name tags command, and whatever image name you have, v1 You can give the same name, LW Web, but your name should be start with your account name. So in my case, account name Vimal 13 slash. So whichever image you have, while creating, you can give the same name, or after this also you can change the name. You can Docker images, your name change. Now after name change, you can upload this image. How? This called Docker push command. Push command. Local system stored in my local repository. I'm uploading to Docker Hub. Docker Hub. My push command. My rule is your image name should equals to start with your account name, whatever you created, and before this, obviously to first login. Now your image has been uploaded to Docker Hub. How I know? If I go and refresh this page, it is there in the Docker Hub, and this is a public repository I have created here. Okay, I've created here. See here, this is what uploaded, and this image I have given a tag or version called V1. That's what you can see here. I might have some other older image also. There's a different point, but it is there. Okay. Now, anyone, you guys can also download this image and run there. And this is also a good way to share your entire system. So I have created this image, and I can share this image to all my team, my testing team, other teams, so they can download and run the image. And in this image, they can get the entire app running, so they can test. I directly upload the code in the GitHub. GitHub. Downloaded, pull into one my system, and I also have a Docker file there. I build and get the image, and this image I push to Docker Hub. Okay, and right now, guys, this part I have done it, but if you want this part to be done automate because my database keep on changing the code. Maybe this possibility in my laptop, and they find some more thing in this app to be changed. Maybe from welcome to nice word, they want to give a new line here. So buy, for example. But after change the code, they commit, let's say, new change. But after they push, the new code gonna come up in the GitHub. So let's say the last code have a version 1. So version 2 code gonna come up. What you need to do? New code. And again image create, again upload the image to Docker Hub. So everyone will get the new image. Why? Because in the old image, we have an old version of the code. And the new image, when I create, I will put the new version of the code. And that is also one of the reasons why we always give image versions. Versions. So again, what we have to do, let me go back here. Get clone command to download the code. Okay, and let me do one thing. Let me go to, let me create one more new folder, or maybe we can remove the old one. All right, also load the code. New code gonna come up. Okay, here I already have the file. Let me copy from my other location where I have the Docker file with me. Code. Okay, and Docker file, and let me copy here. I will again build the new image because the code has been changed. image name, but this time you can change the version. Why? So I want to create the new copy of the image with a different version. So I have both the version available with me. Let's go. Maybe when you launch a new version somewhere, let's say in Kubernetes, the new version might not working the way it should work. So if you have an old copy of version 1, you can roll back to the old version that was working till date fine. It's one of the reasons we keep on giving a new version whenever some code change. So new version created quickly. So yeah, there's one more new version gonna come up. Okay, and then again we'll load this version sorry, by changing the name. So this is a version 2. This image I have locally. I will change this name so that I can push to the Docker Hub. So 2 versions I uploaded. Some minor changes, but you have many other changes also. Maybe first version have some vulnerability issue. Have some Trivy or Scout tool find the image vulnerability. My developer again rectify the issue, the change, then we'll rebuild and create a new version. So there are many reasons. Now I can see here there's 2 versions. I'm gonna I add one more version. I have both the copies with me, V1 and V2. Launch this Kubernetes, maybe some in the cloud. If version is working fantastically fine, that's good. If it's not working fine, then I have old version I can roll back very, very quickly. But who helping me to roll back? Okay, so Docker does not have a way to maintaining the versions in terms of rollback. Okay, so if I quickly give this information to you, so my and let's say in the production environment, I am running the version 1 with the old application. My developer change something, I come with a new image with a new code with the version 2, and my new app I want to launch. This is called roll out. Okay, I want to roll out a new version in my production environment. Okay, and if this version fine, working fine, that's nice. If it's not, any challenges, because I have the old version, I can very quickly go back. Let's go roll back. That is the reason we maintain the version. Okay, but for rollout and rollback, we have to use multiple strategies. It is not like this, we just delete the old one. For example, if we just purely go for Docker, okay, then some name here. So I'm using V1 version, and then I can use Docker inspect command. They might give some IP address, maybe let's say 2. This was the old version. It was working fine, but now we know there's new version gonna come up. So what I can do, I will remove my OS. It is completely terminated forcefully. And now because we know the new version gonna come up, so first we delete the OS version, and obviously when you delete, you have a downtime, right? So it was actually working from this guy. Let me remove this one. So the one is running already. Let me show you this demo one more time. So I have no container. Let's say initially we have version V1. Okay. Right. You find and come up. First we delete the old version. Okay. We have our downtimes here. The client is not able to connect. That's not good. Why I do this? Because I want to come with the new versions. So because Docker is very fast, so I can very quickly launch the new version. As soon as the launch, by the key, because Docker is the one who gives this IP address to you. If you give the same IP address, then working again to delete again, come up with this guy. Rollback. There's also manual way. Okay, so so the point is and roll out. Guys, can you again confirm a voice is audible? I is the challenge here. There's no challenge from this side. Now I think now okay, now it's okay. So you have a proper way. This strategies in rollout and rollbacks. Old-fashioned way, delete the things and launch the new one. There we will see something manual or downtime. But if you want to use in proper strategical way, the way could be something like okay. Then parallel V2, my client is sending to V1. Okay. And seamlessly, when the next client gonna come up, we start sending the traffic to V2. Okay, for the new clients. So slowly you can see the V1, they are not sending any traffic. Smooth transaction we can do. So this could be better strategy, one of the better strategy. And this strategy is known as rolling update strategy. Okay. Docker don't have it inbuilt. So here we can take the help of Kubernetes. So whenever you try to launch any version or container of any version, that's called deployment. So for the deployment, we have giving you multiple strategies, which is very common. Okay, my developers keep on updating the code in GitHub and download, come like a new version, upload in Docker Hub. Again, we some more thing come up. So maybe in the days 10 times, 100 times, we might do this. And every time we have to roll out thing. So 1 minute, guys. What to do? Let me hold my mic. Every day I normally take multiple meetings and sessions for the same mic. It does not create any issue. Maybe I don't know. Hello. It could be, I think, I don't know, look like from Zoom side, I feel, I think now it's okay. So here, so it is very common, it is very common that my developer keep uploading the code. We have multiple new versions gonna come up. Someone download the code, build, upload in Docker Hub. Now, again, one more thing I want to add here. This process of downloading code, building image, change the tag, upload Docker Hub, it is your choice. If you want to go for manual, you can go. Otherwise, you can use CI tool here, Jenkins. Jenkins. So in the Jenkins, there's a concept called job you can create. And Jenkins will go on your behalf. They will go and download the code from GitHub. They will go and build the things for you. They will change the one and push. And the beautiful thing about the Jenkins is there's a concept called trigger in the Jenkins. Okay, means as soon as the new code upload in the GitHub, GitHub. So Jenkins keep on tracking when the new code or new version or commit ID gonna come in the GitHub. Okay, Jenkins will automatically trigger the job. So without hitting any button in the Jenkins, they will run this CI pipeline. So my point is, as soon as my developer upload any code, okay, that's all. No one have to touch anything. It go to GitHub and automatically my Jenkins, whatever the way you set the Jenkins as a tool, they will download this code automatically. So there's one concept in Jenkins, guys. So in the GitHub, if you go to settings, in the setting, there's a concept called webhooks. Great. Where you can connect your GitHub to your Jenkins by adding some URL of the Jenkins. So I'm not teaching you Jenkins right now, I'm just showing you this is what the concept we can add. Okay. So it means as soon as I, as a developer, upload my code in my local laptop of my app, if Jenkins is there, they will keep on looking for this repository, or the repository will go and contact Jenkins and say something changed. Jenkins come to this guy, they download this code, means you don't need to run this command by yourself. Jenkins will build for you and push to GitHub or Docker Hub. Okay, and finally, the new version of your image will become up here. And Jenkins, we have a way, because we write some scripts there, we can also keep on changing the version names automatically. So this is the one of the use of Jenkins as a CI continuous integration pipeline. Or maybe we can do with Jenkins. Okay, after my developer upload the code, I can ask my Jenkins, they will contact to SonarQube and ask the SonarQube, can you check the code coverage, code vulnerabilities? Okay, if the code is Java, then I can ask Jenkins to contact Maven to build this code. Okay, or maybe after image create, I show you the image created locally in my Docker engine, and same system where we'll run the Jenkins program. After image create, new version, before we upload, because I know when I upload this image into my hub, my Kubernete is going to use maybe in the browser environment, but before we upload, I can use Trivy tool to scan the vulnerabilities. Let me show you a very quick demo. So if you search for Trivy, a scanner tool, so there's a tool I am talking about. Okay, and if you click on get started, so you have to first install the Trivy. So they give you a way to install the Trivy locally. I have to install this tool. So this is one of the way, because I'm using kind of a Linux system. So let me create the repository here in my Linux system. Technically, this is the way to create the yum. Okay, and now I can install the Trivy as a tool. As a tool. So this tool has been installed in my local machine. And this tool give you a lot of capabilities. So we go, you can, I was talking about cluster scanning and vulnerability scanning and many, many things this tool give you. Okay, this is one of the things I'm talking about. So if you want to check this image scanning, so this tool, wherever you installed, so I can tell this tool that this is the image I created. Sorry. This image I created, Docker, this image. So Trivy, your tool, can you please go to my image called LW Web with V2 version? That's here, they are doing the vulnerability checking. Right now I'm running this tool manually. But what you can do, you can run this tool with with Jenkins. So where you can write after image build, before you push to Docker Hub, somewhere here in between. Okay, we can write one stage in Jenkins and say, Jenkins, can you run the Trivy tool, scan the vulnerability, and if you find some critical vulnerability, don't upload to Hub. If you upload a Hub, my other team can use it, maybe in the process environment. If any vulnerability, just go back, give this report to respective team so they can try to resolve this issue. Okay, so there you can use this. Now you can see they are talking about they have a lot of CVE found. So this image, what I'm using right now, have a lot of vulnerabilities, and these are vulnerability databases. So they have some Vim command issues that is affected. So they have a lot of vulnerabilities is there in this image. Some vulnerability can be just a warning, but some vulnerability can be very much critical. Okay, so these are medium vulnerabilities. These are low vulnerabilities. Okay, the low, maybe we can neglect this called severity level. But any vulnerability that is critical, that is higher chance to have a compromise of the system. So we can use further scripting tool to go and check, are these guys having critical vulnerabilities? If yes, so I can tell my Jenkins tool, you are doing some automation, this called job you're running, pipeline you're running, discard the pipeline there only, don't go for next part of push. But if there's no critical vulnerability, then we can ask them to push. Okay, so we can do. But how to resolve this? Then we have a lot many remediation tool available in the market. If they have any vulnerability, they will tell you how to resolve, which library to use, which version to use. So we can resolve. Okay, and this is the guys, entire thing is normally done by a security team or the DevSecOps team. Maybe manual way, maybe in the automated way. But these tools could be one of the tool we can use in the pipeline. If everything works fine, then we can upload into Docker Hub. Okay, and that normally means that now this image has been built. We have the new code. My code has been checked by SonarQube. My image has been checked by Trivy. We have a lot of unit testing we have done. Devin, if you are using Java unit test or Py unit, if you're using Python unit test, we have done everything. Now this image, everything what we need in CI have done. Now this image is ready to use with this new version I release. Okay. Now to launch this version, okay, 1 minute. To launch this version, okay, we have to deploy. And mostly, guys, the way I explained to you, if you want to deploy in Docker, you can deploy. Thing is working the way I showed to you. Docker container running. My client has a connectivity, everything working fine. The only challenge is if this guys goes down, we have no one to do the fault tolerance. Okay, but one of the main thing is what we're looking for. If new version gonna come up, that is very common. We have maybe tens of different versions gonna come in a day. So there's no one who will manage my strategy, the proper deployment strategy. Without any downtime, how can you roll out a new version? So if your requirement is without downtime, you want to roll out a new version, okay, we have to use some deployment strategy. And one strategy is co-rolling update. Docker does not support this. But Docker is just a container engine. They will launch the container for you. But these strategies, who will monitor, who will relaunch something fail, that is not the goal of Docker. In the Docker, if you want to do, you can do it. There's a concept called Docker Swarm. Docker Swarm, okay, is active at this point in time. So Docker Swarm is a competitor of Kubernetes that work mostly like Kubernetes, but we don't use much because they have very limited kind of facility what Kubernetes provide. So we don't use Docker Swarm. Instead, we use Kubernetes. Okay, so I think this information is enough why we need Kubernetes. Okay, and where we need Docker, or plus where we need Jenkins. So at least you get some idea. So Jenkins, I'm not doing demo. It will be now next discussion because this two company is looking more about the containers and the Kubernetes. So I'm focusing more on container and the Kubernetes tools, and I'm keep on talking somewhere around also. So you have enough understanding what is a nearby tool related to Kubernetes. Okay. So now let's go for Kubernetes. So code will be done by developer. Image will be created by Docker file. Custom image. Everything will be automated by Jenkins. Okay. Then after image upload in the Docker hub or any other hub, to launch this image, mostly maybe in the production environment, there we use Kubernetes. Okay, that's the whole idea. So guys, right now what I'm doing, because I'm going to set up Kubernetes, it takes almost half an hour. Okay, and when my setup is started, then I'll give you time to practice all the stuff what I did till now. Okay, so let me first start the Kubernetes very. Service provider like AWS Cloud. So mostly every given you Kubernetes service in AWS, the service called EKS. If you go to Azure Cloud, then we have AKS. If you go for GCP Cloud, we have GKE. We have Mirantis private cloud known as OpenShift, not OpenStack, OpenShift. That is the Kubernetes tool, and many more. Okay, so so this is what we can use. Okay, but in my case, I'm going to set up the Kubernetes with EKS. There's a plan. So EKS is one service in AWS Cloud who help you to launch the Kubernetes cluster very quickly. Okay, and how to launch the Kubernetes with the help of EKS. Okay, so for this I'm not doing from graphical. Okay, graphical. Again, I'm repeating, guys. I need a Kubernetes cluster, and you have multiple choices you can use, but the use and final use of Kubernetes will be same. But in my case, I am going to use EKS service, Elastic Kubernetes Service in AWS Cloud. And if you want to use this service, then we have one tool available. This is called EKS tool that will help you to set up this service automatically. Okay, so that is what I am going to use. So this tool is, guys, available free in the market. So if you search for EKS install, you will find this tool. Okay, and here there's a link of GitHub in this page, and there's a release here where you can download the latest EKCTL tool. Right now I'm using Windows, so I have downloaded this tool for my Windows OS AMD, and that's what I had already downloaded. Okay, this tool, and I need many more tools, guys. Also, the Kubernetes is a program more like a server. Okay, so this tool we're going to use for the installation purpose, one-time use. But after Kubernetes program or server service started, we're going to use the Kubernetes. So we have to use a client tool, and this called kubectl is a client tool for using the Kubernetes. So this tool also we need. Okay, so kubectl install is one more tool we need. You can go here, and in my base system Windows, so I have downloaded for Windows already. Okay, by some link or maybe by curl command. In my case, all this tool I have copied in one of the folder, because I might need more tools in the Kubernetes. There are a lot of things we will do. So in my C drive, in the program file, I have created one folder called Kubernetes, and I've downloaded this tool here and this tool here, and this folder I set by path in Windows. Okay, it means if I open my command prompt, this tool I can use. Okay, so now from my Windows, I can use EKCTL tool to create the cluster. But one more thing I need, this tool is going to launch the cluster of Kubernetes. What is cluster? We'll see in a minute. Or I can say Kubernetes program in AWS. And you guys know, if anyone want to go to AWS cloud, you have to first log in, right? And for login, right now this tool I'm using in my Windows operating system. So in the Windows, you have to put keys somewhere of your AWS cloud. Okay, and for this, it's again one-time setup. You need to do two things. One, you need AWS command line tool, so it will help you to store the key in your local Windows. And second thing, you have to create a key in the AWS account. So what I mean by this, I need one more tool. Let's go AWS CLI install. So the tool for AWS cloud, and this tool will help me to store. If you click here, okay, for my Windows, you can click and download the software, install it. After install, okay, you can use AWS configure command. It will ask you the key that is going to store in your local machine. And this key you have to create from your account of AWS. How? You guys might know. So in this AWS account, in your top right corner, where your name is, you can go to security credentials. Okay, because I would like my tool will log into my AWS cloud to use some services. So you have to create a key. So they only allow two keys. I have some key pre-created. Let me delete. some of my old key, so I can create a new one. Okay, so I am going to create a new key here. Okay, and this key, access key, is more like a username. I'm posting here. And one more key I need is secret key, is more like a password. And then I would like to use all of my services in AWS Cloud to be used in AP South 1, that is the Mumbai region. So I type AP South 1. I want to use everything in Mumbai, and that's all. So this is a one-time setup, guys. Okay, this setup will put the key in your local laptop, and ekctr is a command who will install the Kubernetes. Install the Kubernetes, but behind the scene, they need a key to log into AWS. So first step, what I did, I copy the key. The second step is I am going to launch the Kubernetes cluster. Okay. And then finally, after Kubernetes launch, it will take almost 30 minutes. Then I can use this command to use my cluster. So how to launch the cluster is very simple. Okay. So this command is like an automation program. So we can say eksctl create a cluster. What a cluster will see. You can think for a minute, it is more like a server or services. And I'm giving the name, let's say Linux World Cluster 1, 2, 3. That's all. One click, your entire cluster will launch in the AWS cloud. Okay, that's all. They start working, and cluster is creating with this name. Okay, so finally, what you will have this cluster. Why we need this cluster or server? Because I need Kubernetes. And why I need Kubernetes? Because I have created an image v1 v2 with Docker file. This image created by you or by Jenkins, whoever created does not matter. This image, and this image I have to run as a container. You can run with Docker also, but Docker we have challenges. They does not have a proper deployment strategy support. They does not have any fault tolerance or resilience support, and many other support also. So image creation to be done by Docker engine. Then image will upload somewhere in the Docker hub or any registry. Then deployment of the image I want to do on the top of Kubernetes, because they support these things, what I told to you already, and many more support also. Okay, that is the reason I am setting up the Kubernetes. Now it will take almost 30 minutes to launch. Then I'll show you how to use the Kubernetes cluster. Okay, now what we'll do, guys, very quickly. By the meantime, this setup is going on. I'll go for Q&A very quickly right now. Okay, after 5 minutes of Q&A, then we'll take a pause from my side for almost 45 minutes. And I suggest do the step what I've done step by step. Maybe I have done a lot of discussion here. Okay, but do those steps one by one. If you want to take this URL, I'm posting this URL where I put my Flask code if you want to test same way. Okay, so go to this app, this location, then use the Docker file. If you want, I'll also post the Docker file there. So let me go to my local machine and let me create the Docker file. So let me also upload the Docker file to same location. So if you does not want to create the file by yourself, you can create. Okay. So in this location, you have both the things. Download this git by git clone. Then in one of the machine where Docker engine running, go and build this file, create your own image, upload into your own Docker hub. Okay, and then launch the Kubernetes program or cluster, so that this image I'll show you how to launch in the Kubernetes. In the Kubernetes. Okay, and we launch the Kubernetes, and you can see all the capability what Kubernetes provides to you. Okay, this is how we can see. So what you can think till now, what I have done, let's say is done by Jenkins, let's say. So this is more like CI part, continuous integration part. And now after image created, now this image I'll take and deploy in Kubernetes. It's called continuous deployment part. Okay, this is what we are doing right now. Okay, but in this deployment part, I'll show you some challenges, and that challenges we will solve by Argo CD. So that we also do after we do some setup on the Kubernetes. Okay, so I want to take a pause, guys. Here, a lot of information I given to you. I'll try, guys, my best to touch everything. Obviously, I can't train you in the entire Docker or Kubernetes or entire DevOps in 1 or 2 days, but I'm trying to touch as much as possible. As in a way there will be no prerequisite step by step. So those who by chance new, they can also link, and those who already knows, they can see a kind of proper approach and proper concepts in theoretical and practical way. But I'm only picking those concepts of Docker or the Kubernetes that could be asked and should be asked in both the company interviews. That's what my focus area would be. Okay, so any quick queries, guys, if you want to ask me till now. So the difference with CMD and the endpoint, Rahul, I will discuss you in some time. I might have some demo for this, but very quickly, if I can elaborate right now. If you have an app, okay, if you run this app automatically when the container run, that is done by entry point. Same thing we can do with CMD also, but I don't recommend this. We use entry point in the Docker file. But if app, sometimes your app has some sometimes you get an app, okay, and that app will ask you the command line arguments. Okay, right now my app does not ask, but sometimes when you run the app, so while running the app, they ask you to give some command line argument. This argument they will take as input and use somewhere. So if you have any app that is having any command line argument, if they need, okay, so how can you pass this argument with Docker file? Because in the entry point, we just write Python and the app name. Okay, if you give the argument also, then hard coded. You can also give in the entry point. But I don't want my argument to hard coded. I want it could be keep on changing every time when someone run this program. Okay, so there the role of CMD keyword come in play. CMD keyword means whenever this program run, by launching the container from the image. So while launching the container image, you run command, in the last of the image, you can give the arguments like this. Like this. And this argument is managed by CMD keywords. With CMD keyword, you can make it something hard-coded as a default. Otherwise, you can change, they will change on the fly. So this is the core use of the CMD. But if any program that is not asking for any argument, okay, then in this case, you can use entry point CMD, both will work in the same. But they have some more uses. If you use CMD, then this program can be override while launching the container. But if you want to make a container image in such a way that if anyone run a container and they can't override this program, If you use CMD, then they can override by passing the argument from the command line. But if you use entry point, they won't override. So that is some of the few big differences between entry point and the CMD. I was talking a little bit faster here because it's not so much important right now. But you asked me someone, Rahul, so that's what I'm trying to give you a more clear difference. Okay. So very information till now. Thank you very much. Yes, Ankit, you can use Fortify also. Okay. For this, but I found Trivy will be more useful if you want to scan the entire Kubernetes infrastructure. So Trivy is more specialized in this way. Okay. So Parth, we can do auto healing also in Kubernetes. Some auto healing they will do automatically the way I was talking about. But other auto healing, we have some extensions of the Kubernetes called CRDs. Plus, we can also create some rule. That is what I was talking about. Okay, if something is not working that way, we can do that part, something like this. So get some conditions, rules to do the auto healing. Okay, but the example what I was talking about, if one of the container goes down, so they'll launch automatically for you. You can also consider as example of auto healing. Thank you for explaining this concept in an amazing way. Thank you very much, guys. Yeah, that's what readiness probe you can use. This is what I was talking about. So probes you can use to see the health, and if health is not right and proper, your thing is not ready. So we can ask the Kubernetes to relaunch a new thing, and many more things we can do on the top of these tools. Okay, so guys, I right now, because there's a lot of things you have to give the information, so don't consider I am teaching you actually. So this is not actually my methodology of teaching. I normally start from very basics and slowly I build the layers with a lot of real world use cases when I do the trainings. Okay, right now my plan is to just give you a lot of information, so that when you have an interview in Accenture or Sinji, you should know the vocabulary, because mostly in the interview only the vocabulary and the concept and architecture diagram help you. So that was the plan. Okay, that's it. So Splunk is also a tool, but Ankit, it is useful mostly for the log monitoring, even though they have APM or SIM support also, but it is meant for log management and the monitoring. Okay, the monitoring is a big word. Depend what you want to monitor. You want to do tracing, you want to do metrics monitoring, you want to do many more things. Log monitoring we can use. Okay. Uh, so now what we do, guys, I suggest let's do you guys do this demo. Okay, and now what I'm doing, we are opening your WhatsApp group. Okay, so if you're facing the issue in some of the console while doing the demo, so my lot of team is there, they will help you, or we have a Discord channel. My team also update you the link of the Discord channel, so you can put there. My team gonna help you if any practical demo. Okay, so we will join back from my side. I will join back and at 6:30 IST time, and now there after this we will start doing the practical of the Kubernetes. Okay, so take almost 35 minutes. Okay, to do these demo and also ask the query to my team. Okay, so I'm just logging out. Maybe there's a possibility your meeting might disconnect in between. So if the meeting look like ended or disconnect, don't worry. At 6:30 we will again start the same meeting, same link, so you guys can join back at 6:30. Okay, so that's all guys from my side. Do this demo and practice. I'll connect you again at 6:30. Bye, take care. next part. So in my case, my Kubernetes cluster has been launched successfully. So this was the command I ran, right? And you can see in the last line, it is running and ready to use. And this was the command I used to launch the cluster. So now what we have, somehow maybe manual way, or maybe if you know Jenkins, the concept I explained to you, we have created a custom image, and this image I uploaded into some registry. So we have the custom image, or maybe the Docker image. Okay, now it is your choice. You want to launch the image on the top of Docker host. So there's one OS running with the Docker engine that's called Docker host. So you can launch this image as a container. Okay, and because in this container we are going to run the app, so I can say this is an app container. Okay, on the top of Docker host with the Docker run command. This is the one of the way you can do. Or other way would be, okay, I can use the Kubernetes to do the same thing. Only difference would be if you launch with the help of Docker run command. So Docker does not give you a capability. What I explain you, what Kubernetes give to you. Okay, so what we can do, instead we manage the Docker host by ourselves, because right now we are managing the Docker host with ourselves. That's called manual way. Now what we can do, we will have same Docker host. There will be no change. Okay, because container, if you want to use, you need container engine. One of the engine or the manager is called Docker engine. So what we can do, we have one computer running with a Docker host, okay, and giving you a container engine that's called Docker engine. Okay, so setup will be the same. Okay, but now we are not launching the container directly on the top of Docker engine. What we can do, we can have one more computer running with a program called Kubernetes, and asking the Kubernetes, now you will go and manage this computer. Manage this computer. In this example, this computer is also known as host or the node. So we can ask Kubernetes, you will go and manage the Docker node. Okay, now we are not going to, as a human being, we are not going to contact to Docker engine anymore. Okay, instead what we can do, we as IT engineer or the DevOps engineer, we will contact to Kubernetes program or services using a tool called kubectl, is a client-side tool, and ask the Kubernetes that we have some image there in the Docker hub, go and download this image and launch this image as a container on the top of this Docker host. And the Kubernetes is launching a container. Okay, so in the world of Kubernetes, this container is technically known as pod. That is almost equals to container. Okay, and because Kubernetes is going to send this instruction to the Docker engine, behind the scene Docker engine is the one who actually launch a container for you, but you are not launching directly. Kubernetes is launching on your behalf by contacting the Docker. So for the Kubernetes perspective, okay, this container, they use the term called pod. And pod is one of the keyword or one of the feature of the Kubernetes. So there's one point. Second point, what I want to add here is, because Kubernetes is the one who is helping you to launching the pod, so they have a capability. What we can do in the Kubernetes, there's one more internal program of the Kubernetes, and this program is known as replication or replica set. or replication controller. This program, what we can tell to this program that hey, we launch one pod. Okay, now your duty is to keep on monitoring this pod that is almost equals to container. And what I'm asking my pod to be always up. And if you found this pod goes down, then this is your duty. If it goes down, then it's your duty to make this pod up automatically at the same point in time. It means this is the duty of the replication set or the replication controller is one kind of, again, keyword in the Kubernetes. This is called resource of the Kubernetes. Okay, and what this resource will do, this will make sure your pod is to be always up. Okay, so the XYZ region, if it goes down, obviously app will goes down. So application set will automatically make your pod up or the container up. Okay, this is one point. But I told you right now you can think there's small difference, but you can think pod is almost equals to container almost equals to OS, and OS is the one where we are running the app. I told you app we dockerized in an image with the Docker file. Okay, and I also told you the code change of my app, my image also we keep on changing by giving multiple version, old version, new version, and many more versions. So maybe I am running with a pod with V1 version or container from the older image or V1 image. Okay, if the new version gonna come up, so I want to roll out the new version. And for rolling out, we want to use some kind of strategy. One of the good strategy I told you is called rolling update. So for this also, we have one more keyword in the Kubernetes. This is called deployment. Deployment. Okay. So deployment is one keyword. This is called resource in the Kubernetes. And what deployment can do, in the deployment, we can decide what strategy we would like to use when the new version gonna come up. For example, V1 version is the old image. If you come with a new version, okay, so you would like to use rolling update strategy. The way I explained to you, rolling update means you will run both the version together. Both the version together. Okay, and slowly stop sending the traffic to old version and send traffic to all the new version from the client. This is rolling update. Or you want to go for some kind of brutal strategy, means you remove the old version completely, then they launch the new one. Okay, this is called recreate strategy. So maybe you can face some downtime, some second, but sometime we might need, so that also we have. Okay, so typically what we do, this is the normal process. Whenever you want to launch the container, that is your app container where app is running, okay, your container is being launched with the help of pod keyword in the Kubernetes, and pod is being launched by replica set or managed by replica set RS, and replica set is managed by deployment. Okay, so what I mean by this, whenever you want to launch the app that is there in the container from the image, this is called Docker image that we already created. Okay, but for running the container, we can't run the container directly in the Kubernetes. We have to take the help from pod. Okay, but who will maintain the guarantee of the pod? Pod is keep on running or fail. If they fail, they relaunch the replica set. But who will manage the replica set, or who will manage the strategy of this pod? Maybe this new version gonna come up. So I have to tell my replica set, whatever you are running behind the scene, version 1, slowly you have to launch version 2, and so on. So there's a lot of keyword actually in the world of Kubernetes. I'm just trying to give you very, very quickly. Okay. So let me go to command line. My Kubernetes is running here by this command. And I have a command line tool also installed already, kubectl. And you will see how many ports we are running is nothing. It will show in a minute. Nothing. Okay, the new setup. A port behind the scene is managed by replica set. RS is a keyword here. This is called resources. You have no replica set. And replica set is managed mostly by deployment. So we have no deployment. But if you want to launch a port that is equal to container, then we have a command called kubectl. I want to create a deployment, not the pod. Okay, not the pod. We are creating a deployment, and deployment we can give the name. Let's say my web is just a name, and here I would like to use the image, and you can give any image, either is given by someone in this community or whatever image you created. You can give the name of the Docker Hub image. Okay, and obviously with the image you give the version also. Let's say I want to give v1 as a version. That's it. There's only command, and it's so beautiful command. Now what you see here, Kubernetes. So technically, if you according to my diagram, I am here in my local Windows as a client. I have this command. That's what I am running here, and I'm telling my Kubernetes this is what the image I would like to use. Okay, and Kubernetes will take this information, okay, and send this information to some of the Docker node running somewhere. And there's also possibility, instead we run one Docker node, we have many more Docker nodes also, 1, 2, and 3, and so on. Because Docker node is the one where we run the container. Container is the one who need resources, memory, RAM, CPU. So they take from the base computer in the shared format. But this base computer has a physical limited resources. So one node is not enough to accommodate many containers. So what we can do, we can have multiple nodes running. It is something like this. So we have one individual computer running with Docker. We have one individual computer. We have a lot of RAM and CPU. We have one more computer running, or VM running, with one more Docker host. And all the Docker hosts to be managed by one centralized Kubernetes program. Okay. So in this case, this guy is managing this also, this guy managing this computer also, this guy managing this node also. So whenever any IT engineer who contact to Kubernetes, a client, so Kubernetes is very intelligent. They see this computer may be filled with resources. This computer B might not have the RAM available. The C is kind of free. So they will go and launch the new pod and container here. So this also have a program called Kube Scheduler program who schedule, okay, which node or which Docker host the resources available to launch the content. So in this case, this computer is normally known as master node or the manager node. And these computers are known as slave node or the compute node or the worker node. And normally multiple computers work together as a team. That's called cluster. That's called Kubernetes multi-node cluster. So mostly in the Kubernetes, we use multiple node. And one of the benefit is if by chance, if this node entire computer goes down, Kubernetes computer node, this entire computer goes down. So whichever the container running here, they will relaunch again to different node, which is running at this point in time. So this kind of fault also they can tolerate, or this called failover. They can solve for you. So right now, if you want to check, okay, let me open one more terminal. We want to check at this point in time, how many nodes we are having. Okay, So I am using EKS cluster. So by default, with EKS CTL command, they give me 2 worker nodes. So these are individual computers, okay, running somewhere in the AWS cloud. But both the computer has Docker installed. Both the computer can run the container, okay, and that is managed by the master node. And right now, because I'm using EKS service does not show the master node. They are managing the master node behind the scene. That's called serverless concept. But there's one master node somewhere that is managing these 2 nodes. The 2 individual computers. Okay, and now whenever I launch deployment, okay, that is my deployment launch, and deployment is the one who launch a replica set. Okay, and replica set is the one who launch pod. Pod. And pod is the one who run container behind the scene. Okay, so technically, if I talk about this, one command is launching your app in the Kubernetes cluster. The app is running in the container running inside the pod. How I know this? Okay, there's a pod, and if you try to describe the pod to see the detail, so every pod they have a name. There's a name of the pod. You can think pod is more like a container. So if you describe the pod, it will give the details. And what you can see here behind the scene, they pull the image and launch the container. Or maybe if you go up here, they can say inside the pod, they're running a container from this image using some container D or Docker. Okay, so that's what they're doing. Okay, so you can think pod, not exactly, but equal to container. But right now, one pod is running. Okay, and because this pod is run until managed by replica set. Replica set. Okay, this is the duty of the replica set. Okay, to keep on running this pod. Means by chance, anyhow, if your by chance, anyhow, if your pod deleted, I'm doing it manually. There's a pod name. If a pod is deleted, accidentally or manually, intentionally, okay, you see, guys, as soon as pod deleted, because my replica set behind the scene managing this guy was somehow, okay, so they relaunch this pod again. So you know, you would be like a hands free, and and as soon as the pod delete, okay, without you launch again, as any fail happens, so they will automatically recreate for you. So they're deleting here, and as soon as you delete, you can see your new pod automatically launch. See, 30 seconds ago, they give every pod a unique number. So there's an old number, there's a new number, and they launch because of the replica set. Okay, so if you see the same pattern in the Docker, guys, if the Docker content deleted, it does not create automatically, but here they create as soon as they delete, within less than a second, they'll launch for you. And why they're super fast? Because behind the scene using container or Docker behind the scene to launching the container. Okay, this is one thing. Second thing, they have one more interesting facility. Okay, let's say right now a pod is running with a container running with app. And let's say in one app, at most you can connect 100 concurrent users. Just number 100 is just a hypothetical number. So if you have more load gonna come up, so what we can do, we can launch more copy of the containers, the pod. Okay, this is called scale. So there's a command called Kubernetes scale, and I can say there's a deployment name my web. This is what the deployment created. Okay, and in this deployment, I am running with only one copy one copy of my port, but I want to get more copy as the same copy. It's called replicas. Let's say I want to get 5 copies. So same container, they have 5 copies. Everyone is an individual container. Everyone has their own IP address resources. Now this command behind the scene send the information replica set. Okay, and replica set. Okay, get this information, and they say, hey, I know your desired state is 5, so I'll make sure I will create a 5 copy, and now 5 copy ready. Maybe now 5 port are running. They are the individual port because they launch from same image. And this image, guys, I have base Linux, Red Hat, Python, Flask, app. Everything is pre-backed. So launching the 5 apps, 5 individual OS is very fast. Because everything is pre-configured, pre-backed. And everyone will manage a different traffic. Okay. So we can do very quickly scale out, adding more copy, scale in. Maybe if we don't have a load, we can delete some of the copies. Now they will only maintain 2 copy of my container. So yeah, the remaining is terminating, only 2 copy will run. Okay, this is one thing we can do. But one more thing you guys might know. Okay, if you are running with the app, okay, multiple OS, in this case the OS is content or the port. Every port have their own personal IP addresses. Okay, maybe IP is 1, IP is 2, IP is 3. And if you want your client can connect, so I can't tell the client all the IP address because we are adding more copy, removing, so IP is keep on changing. So what we can do in this scenario, we mostly put the load balancers. Okay, and I ask my client contact to load balancer, and load balancer is the one who will send the traffic equally, mostly equally distributed. So first client they send here, second client they send here, third client they send here, fourth they send here, fifth and sixth and so on. So mostly load balancer work in a concept called round robin way, means equal distributed the traffic. So in our case, what I have a multi-port running with same copy. And why multi-port? So I can accommodate 100 client here, for example, 100 here. So 3 copy, almost 300 client can be accommodated, for example, in concurrent. But for this, we need a load balancer to distribute the traffic. So in the Kubernetes, they also have an inbuilt support of load balancers called service, SVC. So in the Kubernetes, we have the internal load balancer or service. So I don't have a service. This is an internal Kubernetes service. What the use of this service we'll talk about. But I don't have a service based on my requirement. So what I'm looking for, I have a deployment where we ask them to launch 2 copy, or let me increase more, 5 copies. So I have a deployment where I ask them to have 5 ports running or 5 containers running. Okay, but I don't have any service who will do the load balancing in these 5 ports. Okay, so for this we have a command called kubectl, and what I want these ports will connect to the outside world by this load balancer. And one more thing, guys, those who know a little bit about Docker, okay, when you launch a container, Docker gives the IP address, but these IP are the private IP address, means the isolated IP address. You don't have outside world connectivity. Okay, and Kubernetes behind the scenes using Docker or container technology. So again, the IP address, whatever given, is a private. So if any client from outside world try to connect to this pod or the container, they don't have a visibility or the connectivity. So in this case also, we can take the help of load balancer. Ask the load balancer that what a private IP does not matter. You will have your own personal IP address. Using your IP address, I want to connect the outside world. this concept is called expose. So whenever I create service, we have to use the expose keyword, and we can say we have a deployment who is named my web. They are running with some kind of multiple port, and all the port I want to put behind the service that is called load balancer. Okay, but I want my service to be exported to outside world. So there's a different kind of service available. If we see the help of this command, so there are different type of service available: cluster IP, load balancer, and many more. If you go for cluster IP, there's a by default means you load balancer also have a private IP, means you won't able to connect to outside world. So if you want to use any load balancer that is running only within the cluster, they don't have outside world connectivity, then you can create a service or load balancer with cluster IP type. But if you want to connect your load balancer to the public guys or internet guys, then you can create a service either node port or load balancer type. This is a type name actually. So what is the difference? So node port is a kind of internal personal Kubernetes load balancer that give you a capability to connect to the outside guys somehow. But load balancer is a very interesting concept. Okay, the concept is, for example, right now my Kubernetes is running on AWS cloud with EKS service. And if you know about AWS cloud, AWS cloud, they have their own personal load balancer. So if you go to EC2 service of AWS, so they have very powerful load balancer that mostly we use. It's called ELB service, Elastic Load Balancer of AWS. This AWS load balancer, and right now I have no load balancer running at this point in time. And Kubernetes is different services. But if you want, Kubernetes will use the load balancer of AWS called ELB. So technically, there are two independent things, there are two independent services of AWS. But if you want, AWS will use ELB load balancer. It's called external load balancer with respect to Kubernetes. Then we can use this type. Okay, so what I can do here, okay, what I can do here, I can tell this command, okay, that I want to use the type called load balancer type. So if you are using any Kubernetes in some of the cloud providers especially, and whatever the native load balancer, whatever they have, okay, let me use this. I'm not going to use my personal load balancer like cluster IP and node port. I want to use my external load balancer, in this case ELB load balancer. Okay, that's what we can use. And one more thing I want to do here, now any traffic come to my load balancer. So because I'm using ELB load balancer, and AWS will give public IP to ELB, so they will have public IP here. Okay, but anyone who come to your load balancer, they have to use some port number. So I'll tell the port number of my load balancer would be less 80. And whenever anyone come to the 80 port number of the load balancer and the public IP of load balancer that's come from ELB, okay, we send this traffic to my main app running on the container, and this app also has some port number, right? And I told you guys in the flowers the port number was 5000, right? So my target port would be 5000. That's all. Okay, this command is so beautiful. We are running this command from the Kubernetes, but behind the scene, Kubernetes is EKS service contact to AWS ELB service. And you can see in ELB service, if you refresh, automatic new load balancers created. See here, fantastic, right? Has created. It's called ELB load balancer. And they launch by for internet facing, means they will give public IP, the public IP or the DNS report. And same public IP you can also see in Kubernetes also, like ADC something. So same thing you can see in Kubernetes also. For example, if I run the get service command, it was not there, but now we can see one more load balancer is created having this public IP. Same IP what is given by AWS Cloud. Okay. And this service, if you describe service, you can give the service name, my web. The service is more like a load balancer, and this service is connected to 1, 2, 3, and 2 more, 5 port. Why 5 port? Because I am using 5 ports. And port is individual container. Every container has an IP address. So there's an option called O wide. So you can see every port has the IP address 190, 81, 170, and so on. And my load balancer has behind the scene connected to these buckets. So if I describe again, so you can see this load balancer service connected to 239, and to the application called 5000 port. One is 133, 5000 port. This is what I was talking about as a dagger. It means any traffic that is coming to your load balancer public IP address, the load balancer will send the traffic to the backend port. First we go here, second we go here, third we go, and so on. Okay, because of the setup. Now how we can check this? Now because we have public IP and this public IP access everywhere, anywhere in the world, so you guys can also try and connect. So when I hit this URL in somewhere in my browser or any devices where I have the internet connectivity on Trivy protocol, okay, I can connect. Now if you notice, guys, there's no error look like that site is down and something like this. There's a different error gonna come up, because if you notice in my Flask app, I have given my endpoint not slash. My endpoint was /info. /info. Okay, so it should work, or my port number. What happened? So it takes some time actually, because they are using ELB load balancer. So my load balancer might take some time to activate. Let's wait for some time. Okay. So status is look like perfect. Health check. 1 minute. I'm just target instances look like. So for ELB perspective, it look like actually they correct HTTP actually is HTTP/info. Yeah, perfect. So by chance they correct HTTP. Perfect, right? Is working. And guys, believe me, whenever refresh, okay, right now I am at the client. Okay, and when I hit this URL, even though you can check also, I'm sharing this URL to you at your chat message. When I hit enter, you are hitting to the ELB load balancer of AWS that is internally connected to Kubernetes SVC. This one, and they are taking the request, and this request is going to one of my port. because I'm running 5 pods. Okay, so your one of the requests will go to any of these pods. Right now I'm just putting every pod is having same copy, so it's harder to visualize at this point in time, but every time you refresh you will have connected to different pod behind the scene. Okay, so my point is we are not able to see the visibility, okay, where my packet is going on. So here the role of Kali or service mesh gonna come up. They will give you the entire visibility where my packet is going on, how many requests go to which port. Right now they're doing the round robin or not, means equal distribution or not, and many more things we can add, we can see. But the thing is working fantastically fine. That means I have done the image build part using CI manually or Jenkins. After image has been created, okay, then we have do CD part on the top of Kubernetes, and for CD part we have used Kubernetes command line tool called kubectl, and there's two major command I use. One is this one to launch the load balancer, okay, and one is the create command to create the deployment. And to scale, we can use scale command to add more ports. But right now, if you see the deployment, we can have shortcut also deploy. I am running with this deploy, and if you see the description of this deploy, my web deploy, okay, so you can see they are using the image with this version, and deploy is the one who launch a pod, and pod is one who run the container from this image, from this version, and they're using a strategy called rolling update. Okay, rolling update, and they're using a rolling update strategy. It means right now I'm using a version 1, and let's say I'm running a 4 pod at this point in time. So if you come with a new version, so what they do, first they launch new 1 copy of version 2, and then they remove old copy. Okay, 25% means out of 4, they will create, 1 they remove, 1 they create, 1 they remove. And everything they will put behind the load balancer. So the setup will be like this. So I am running the load balancer. My traffic is going via load balancer from my client. And right now I'm running with a, let's say, 4 copy of my pod. Everyone using a V1 version of my app. And when you want to roll out the new version, let's say V2, now what happened? Right now my load balancer is sending the traffic to all the old version. But as soon as you launch a V2, new version, so first they launch V2, and when the V2 launch successfully, then the traffic starts sending this guy. And after they launch one of the port they will remove, because out of 4, 25% is 1. It means after a certain second, you will see one client go here, one client go here, one client go here, and one of the client will see the new version. Then after this part done, then we launch one more copy. They start sending traffic to new version, and this will they remove. And slowly they will launch 4 copy, because my maximum replica I want 4, and after they launch 4, they remove all 4. This is called rolling update strategy. So in this case, you see whenever you do rollout or new release, according to the rolling update strategy, you won't face any downtime. Okay, downtime. At one point in time, some of the client can see the old version, some of the client can see the new version. That's okay, but no one face the downtime. Slowly, within some few seconds, your entire new version would be rolled out. Okay, so if you want to see this, so obviously the flow would be something like this, even though I want to show you one more thing here. Let's say I'm running with pod. Okay, and if I delete all the pod, this option all, and obviously pod deleted, no one can able to access the app. And let me run the app with the command line. That makes more sense. So I'm using some git bash tool here. Okay, and this is more like a shell. I can use a curl command on this URL. Your site is accessible. Okay, and in the curl command, guys, I just want to see only my output. So I can use S option, so silent. Only output gonna come up, and I want this curl command is keep on running automatically. So I can run the while loop as an infinite loop. Okay, infinite loop. 1 minute. So I can use a while loop, infinite. I can say do, and I want this command to be run, and I'll wait for 1 second delay, and done. I'm just running some automation program to see the disconnectivity. So you can see, guys, every second output is coming up. Let me do Control C. I want to do one more small thing. After this print, let me give a new line with echo command. So now look like, so every second I am pinging to this side. Okay, and why I'm doing so? Because if I delete all the pod, okay, you can see still I have a connectivity. I did all the pod, still I have a connectivity. Site is not down because of the replica set. As soon as the site down, a replica set will launch launch a new pod behind the scene. And because we asked 5, they launch 5. Okay, so I'm just trying to prove you site is not down. If you do the same technique in Docker, it will obviously disconnect. But here, as soon as I delete, they launch a new one. Yeah, new one. And you have a continue access. But what happens if you launch a new version of the pod? So for this, we have a roll out concept. Okay, roll out. Okay, so what I can see here, I want to see the history of my rollout. Does we have done any rollout? So we have a deployment. Okay, and this deployment I would like to roll out. The rollout is a concept. I want to see the history of my rollout. Okay, nothing is been yet done. Okay, so it means I'm still using the old version. So if you want to put the new version, then we have a kubectl, the set command. In set command, we can update the image. Okay, so I can tell my set command I want to update the image. Again, if you see the help of this command will tell you want to update the image for which container. Okay, and plus you want to set the image for which deployment. Okay, you can give the, because we might have multiple deployments also. I say I have a deployment with this name and I want to update the image. Okay, so what I mean by this, whenever you launch a deployment, they launch a pod, and inside the pod they launch a container, and container they give a name. So in my case, this is the container name. It mostly equals to the name of your deployment, this image. So what I would like to do here, I can say I would like to update my deployment known as LW web is my deployment name. We mostly use slash to tell deployment name. And what I want to do here, we have a container. By chance name is called LW web. You can change also. And this container, I want to change a new image. New image. Name is same, but my version is v2. That's all. So what I'm doing, so I have deployment. I'm just trying to describe the deployment. I have a deployment, okay, running with a pod that is running with a container with this name. So this container LW web, they are using the image v1. Now I'm changing to v2, and I'm changing the image for the deployment. This is the deployment name. My web, actually, my web. So my web deployment I'm changing, okay, and I'm changing the container name from this image, okay. But because your deployment already exists, they were using v1. Now they see you're using v2. v2. Now what they do behind the scene, okay, what they do behind the scene, you can see the rolling update. So if you run this command, got ports. You can see 5 ports running, and they don't shut down the port. And you can see your applications, they are hitting the version 1. Version 1 here. You can see the real time. Real time format. The application is still running. And as soon as I hit this command, your new version update, you can see here, now they kick in. See, some of them go terminating, some is creating. You can see new version gonna come up without any time. Without time. Okay, you can see some terminated and some are running. Without any downtime. See, there's no downtime gonna come, right? You have rolled out successfully a new version with this command. And now here, if you see the history of the rollout, okay, you can see there's one more revision gonna come. Means there's one history created. Okay, and you will roll out to the new version, and working fantastically fine. Or maybe new version is not up to the standard what we are looking for. We have some bug, my customer is not happy. Okay, so at any point in time, we can roll back older version. Okay, and for this, we have undo command. Undo means whatever you have initially, last version was right now is 2. Even though we can check also very quickly, now port is running perfectly fine with the new version. But right now, my current version of my deployment was 1, now is 2. Now it's 2 here, fantastic change. And you can see the scale up and down, 1 by 1. Okay, so they send to 5 to 1, 2 to 1. This is what I explained to you. Okay, but as you do undo, okay, you're hitting to the new version. When you undo, same rolling strategy will update, and you can see now they very quickly move to new version. There is no downtime. If you see the port, again the same strategy. Okay, they're terminating all one by one, and because the container is doing very fast, that is the power of the container. And if you describe the port, you can see that you will again go back to same one, because we undo is roll out. Sorry, roll back. If you see the history, they maintain these by time you can change. Okay, so this is a very important concept. The key is Again, if I again describe to you as a quick note, then we have a quick quiz, guys, for today. The key is, let me start from here. We have some idea. We have some idea, and based on the idea, my developer team has created an app. Okay, or in this app, they come up with one more endpoint. Let's say slash Linux world, or let's say slash me. I'm giving my name here. Vimaldaga. Okay, so they add one more function, one more facility. Okay, so this is what the developer has created. After they create, and I didn't need to change anything in Docker file because I'm copying the entire code as it is, nothing extra we need. Okay, so now after this, my git add I have done, git commit I have to do here, new change, bug fixes, and I go to git post. That's all done. And as soon as you do this from the developer, everything will be completely automated because my my Git hub is being monitored by webhooks, by Jenkins. I didn't set up here because we don't need right now for this training. Okay, but there's a lot of powerful pipeline as a code and many things we can do in Jenkins. If Jenkins there, they will automatically come to know. And what Jenkins will do, they will run these commands, what we run in the manual way. So what Jenkins can do, that I explained to you, let me do it manually because I don't have a Jenkins here. 1 minute. So let me refresh the machine where my Docker is running. Okay, and I'm doing manually just to quickly revise. Okay, but if you have Jenkins, now everything will be automatic kick in. Jenkins will download the new code automatically. This is called pipeline, CI pipeline. Okay, so they will download this code in the machine where Jenkins is running, and Jenkins is a machine system we mostly run in the computer where Docker is there, or in the Jenkins there is the concept called master slave model. So Jenkins also have master and slave. So mostly we run the slave computer of the Jenkins in dynamic provision concept. That is not need to right now require to know. Yeah, if you want to go more deep into learning of DevOps, then you should learn Jenkins from end to end. Let me do without Jenkins. Okay, so what we do, we will download this code. Okay, so this is a command number 100, so I can directly run this command 100. So they download this code. Jenkins will download. Jenkins will run the Docker build command. And here also they can give the same image name. Or let me use the same image. Let me use the same command what I use already. And this time they will give new version. That's important. The new code gonna create it. It been built. Now they will change the name to the new version. It's completely done by Jenkins. Jenkins, we have way to this keep on changing number on the fly dynamically. And then we push this version. So that's all the Jenkins role completed. Yeah, behind the scene, we can check the code with SonarQube. We can check the vulnerability with a Trivy tool or some other tool, or many more things we can do. Okay, but as soon as the image will be published here, okay, so these guys also have some triggers and hooks. They can contact Jenkins, and Jenkins will contact to Kubernetes, and there Jenkins can run this command. Which command? This command. So this command right now I'm running manually, but this could be done by Jenkins. Okay, but there's some challenge in Jenkins because this deployment part we can do with Jenkins, but there's some challenge that I talk about tomorrow. So we don't want this command to be run by Jenkins. Instead, we can use Argo CD to make this thing automated. Why? We'll discuss tomorrow. But let's say we are doing manually or with the help of Jenkins, we can run this command in the system where Jenkins is running as a client of the Kubernetes. Okay, when I do so, so what you will find right now, my application is not able to access this URL. That's called me because it's not there in my older version. Not found. Okay, me. But as soon as you kick in the new version, okay, you can see in some minute if I write my right code there, okay, you will see that will be come up. My code is right, but I think you understand the entire concept. So this there. If I see my pod, okay, now pod is error. There would be something I did wrong in my image because I run very quickly. So maybe I have some syntax error in my code. That's what they are not able to run and they try to relaunch. They keep on restarting. So whenever we see this kind of error, that is mostly because your image have some issue. So I don't know, check the app that I write. Okay, I don't know where I create an issue. Issue is obviously simple. I give both the function as same name, obviously, right? So I give a different name to this function. But Kubernetes is smart, they know the error. Okay, and because they know the error, they're still running the old version. So the older client who is connecting to my app, still they can see the outcome because some new version have the issue. But I rectified the issue. Same thing I can repeat again. That now you understood. I upload this code. I think this is the only challenge I feel. Yeah, it look like same thing. Let me do very quickly. Git add, git commit, something, dot get push. Okay, and now Jenkins kicking automatically. So first Jenkins will download this code, then Jenkins will go build. Now this is the new version I would like to create. Then we change the version before upload. Then we'll push the version. Fantastic, right? The CI part complete. Okay, then we use CD pipeline, the Jenkins contact to Kubernetes by connecting Kubernetes client. So Jenkins could be a Kubernetes client. Okay, and they have to run only rolling update by changing the image. If this time I write the right code, you will see they're stating the old version. Okay, if I write the right code, yeah, fantastic. So now you are connected to the new version of the app without any downtime. Okay, when downtime because I still have the old URL also working. This also working and my new URL also working perfectly fine. Okay, so I think you now understand the power of Kubernetes. This is the sum of the facility. Kubernetes is a big tool. There's so many things. We have a CK training, CKAD training, CKS training. So individual training available in Kubernetes. But I'm only talking about some of the important facilities. Okay, that you should know for the interview. Many more things we will discuss tomorrow, but I think this makes sense. Okay, but today I have launched my app in the Kubernetes with kubectl command. Okay, but that is not again recommend. Okay, we don't recommend nowadays to use kubectl command. Why we'll discuss tomorrow, and we'll replace this command with argo cd. Okay, this part we'll do. Then we will tomorrow, guys. We might launch some microservice also app, and then we have a lot of traffic visibility. We can use Kiali. Then we'll talk about Prometheus and Grafana for metrics monitoring and visualization. So these are the very interesting topic. I'll show you with complete hands-on. And now you understand, I believe. So in the morning, I was talking about a lot of concepts. I think now you can be able to relate. Okay, which particular DevOps tool can be used in which particular scenarios. Okay, that's what I can now you can relate. But when we add tomorrow some more practical concept, you will become more comfortable with many other tools also. Okay, and tomorrow we will work on some project which is called microservice app, where almost all the interesting tool, Docker, Kubernetes, Prometheus, Grafana, Service Stream Mesh, Argo CD, we connect together to create one fantastic project. Okay, that will help you input in your resume and your profile, because having the project in the portfolio with practical exposure, because if you have this kind of project, then mostly interview will be around the project, whatever you guys have worked on. That will give extra benefit because you will know tomorrow completely hands-on and practical about that project. Okay, so guys, any query? Because we have one quick quiz right now. There's a last quiz for the day. Okay, so we'll start a quiz in 5 minutes. Okay, but any query if you have, you guys can ask me. I've seen some of the guys drop. I know this is a full day. I'm trying my best to give as much as time and speak as much as I can. I'll try my best to touch everything practical or step by step, but something I can't go more basic because of the 2 days time limit, and I have to prepare very quickly for the job because they have urgent requirement. So anyone who is known, there is a part of this training today, but because of something they might not able to connect the dots. I suggest you guys can also take a responsibility, okay, to help those guys to make them understand. So at least they can apply for this job. Okay, so that's what I can recommend you guys if you can do so. So that's all. Any queries if you have, you guys can ask me. Otherwise, my team will start the quiz. So Sayed or Dilip, if you're ready with the quiz, let me know, please. Or you guys, if you have any query, you guys can ask me. So Dilip, I think as such we have no queries, I believe. So Piyush, this is not the project actually. Today I am just explaining the concept. Okay, tomorrow we will work on some project. So that project you can put in your portfolio or resume. Okay. So we need to copy the code on the host cover and then use. Yes, this should be the right practice, Prashant. Why? Because mostly we download the code once and keep on creating the multiple images. But if you downloading in the image directly, then it will be extra load. Every time you create an image, you have to download. But that is also not wrong. You can do so if you want. But mostly the good practice is first you copy the code in the local system manually or with the help of Jenkins, and then you copy command to copy inside the image in the Docker file. Okay. Yes, guys, right now, one more last thing. The Kubernetes I'm using EKS cluster. EKS service is not free actually. Is not free. Okay, but there's not so much high in charge. I think some $0.1 or around almost 10 cents they're charging per hourly basis. I think that is enough. I think that would be okay for practicing. So after you practice with the cluster, then you can find out the EKS cluster name if you forgot the name. Okay. So after you think your practice is done, you can delete your cluster. Otherwise, every hourly they keep on charging you. So again, to delete, with the same command we can use EKSCTL delete cluster name. In my case, LW cluster 1, 2, 3. Okay. So instead of create, you can use delete command. It take 5 minutes almost to delete the entire cluster. Okay. So this is one thing we can do. Tomorrow time would be same infrastructure we are going to use tomorrow practical. So I just need EKS cluster. Your app could be different tomorrow to explore more thing, but the setup would be EKS cluster. And that's all. Rishikesh, what we are doing, my team is doing, whatever I'm typing here, all the diagram, all the screen, my team is keep on providing the screenshots in the Google Drive, so you can refer those document as a reference. Or we also try to, after having 2 days of this class, my team will go to the video again and they will put all the command as a quick reference note to provide you. But it will take, I think, 1 or 2 days to reach to you. By the meantime, you can take the screenshots to see. So I got offer letter from Accenture, from some associate. So, but I gave the interview for DevOps. Is it possible for them make them DevOps engineer? So for this particular case, Raj Lakshmi, you need to contact to Preeti. She might help you if something is possible. Okay, but cloud job could be good because you can also take a role of cloud DevOps engineers. Okay, so from the cloud associative, then you can go to cloud DevOps. Okay, that's also have a good role in the package and profile. So that could be good way to go ahead in DevOps. But otherwise, if it's possible somehow, we'll definitely help you. So connect to Preeti tomorrow after we complete this program. Okay. So yeah. So guys, my this was the history of my last command. I don't know why this screen come like this. Yeah, that's all, guys. See you tomorrow. So we have a quick the quiz. So Sayed and Dilip, over to you, please.
Thank you so much. So guys, we're just sharing our screen back here. So this is the QR